Sir, am I audible to you?
Yes, please.
Okay, sir. Welcome, sir. Good
You
morning.
are
Mr. P.K. Mishra, Director General of INSDAG is here with us. He'll be connecting with us online.
yes, madam. I am here.
Yes, sir. Welcome, sir. Good morning. Okay. Muted है. हाँ, इसमें लोड करना है.
ये मेरा होगा इनका नहीं.
हाँ. Okay. Fine. So which one?
हाँ मैं उसको ऑन कर लूँगा. अभी आप बॉस के स्क्रीन पे रखो. स्टार्टिंग में
10 minutes चला था. In 5 minutes. So we'll be starting in 5 minutes.
Okay, madam. Thank you.
ये टर्न कर दीजिए. ये टर्न कर दीजिए कैमरा. कैमरा. ऑडियंस. Zoom ऑन कर दीजिए. कैमरा दिखा दो.
नितिन सर वो वाला ऑडियंस.
और सेट कर दो.
पॉइंटर और माइक आ गया. माइक
हाँ पिता हेला
Um, Now, the today's seminar is going to start. I request everyone to please have their seats. Good morning, everyone. I, Astha Sharma, welcome you all to the one-day technical seminar on reimagining construction paradigms, steel for the next generation, jointly organized by the Department of Civil Engineering, IIT Indore, and Institute for Steel Development and Growth, INSDAG. Today's seminar focuses on advancing steel-based construction through innovation, sustainability, and modern structural design practices. We are honored to have with us distinguished dignitaries and participants from various industries, respected faculty members, professionals, research scholars, UG and PG students. Before we begin our inaugural session, I request all the dignitaries present here to kindly come forward for the lamp lighting ceremony to start the auspicious today's seminar. I request our chief guest, Dr. Abhay Gupta, our respective speakers, Mr. Jayesh K. Jain sir,
पानी पानी
I request Bhatia sir as well to join. Ashutosh Kutumble sir, Bhatia sir, Head Civil Department, Dr. Gaurav Sil sir. Yes. I request Dr. Gaurav Sil sir and Professor Sandeep sir and Abhay sir to take the place on the dais. Please. To begin the inaugural session, I now invite Mr. P.K. Mishra, Sir, Director General of INSDAG, to deliver the welcome address to all the participants. Sir is connected with us online? Yes, sir.
Thank you, madam. Am I audible?
Yes, sir. Yes, sir.
Okay. Uh, very good morning to all of you. Uh, Dr. Abhay Gupta, eminent structural engineer, director of Skeleton Consultants, and an esteemed member of the Executive Council of INSDAG. We are thankful to you for having accepted our invitation to be the chief guest of this function. Professor Abhirup Datta, Dean R&D, IIT Indore, Professor Gaurav Seal, who are in the dais, my dear participants, and other faculties and professors who are present here. At the outset, I must convey my sincere thanks to Professor Subhas Joshi, Director IIT Indore, for having given us the permission to conduct this seminar. Our sincere thanks also to Professor Sandeep Chaudhary and Professor Pawan Kankar, who have helped us to make this event happen. Also, my thanks to Mr. Jayesh Jain and Mr. Asutosh Kutamble for having agreed to speak in this function. Why INSTAG is doing this kind of events? If you kindly, I'll request, please have a look at our website. You will see that INSTAG is an institute which has been instituted 30 years back by Government of India and all the major steel producers to propagate the knowledge and awareness of steel application. In our country, per capita steel usage is low, is hardly 103 kg, whereas the world average is about 223 kg. China, Japan, they're all above 450. China is about 650. Korea is 800 kg per capita. So if you see the usage of steel in advanced countries, we are nowhere. Why it is happening? Because the knowledge of steel application among our professional is not that good. In fact, when I was discussing this subject with Professor Sitaram, AICT chairman, who himself is also an eminent structural engineer, who was a director of IIT Guwahati, he admitted that when I told that sir, there are not many faculties who are conversant with steel designs in tier 2, tier 3 colleges, he told, what to talk about tier 2, tier 3 colleges, even in many IITs and NITs, you are having hardly any professors who are fully conversant with steel applications. So if the faculties do not know much about steel or they have not been trained about steel designs, obviously there will be a kind of gap and the students will not come to know. Whereas today the market demands lot of application of steel, lot of construction of steel is taking place, and if you go abroad, you can see almost all the major constructions, particularly the public utility structures, they're all made in steel because they are designed for a design life of at least 100 years. In fact, we are in Japan. 1 year back, government had sent to us. I had gone along with some of the IIT professors, Professor Siddharth Ghosh of IIT Bombay and Professor Madhavan of IIT Hyderabad. We all found that the design of any public utility structure or any kind of large commercial building that they are constructing, the basic consideration is that the structure will last for 100 years. Now they are trying to make codes, etc., for making the structures last for 200 years. Whereas in our country, if you find this kind of concept is not there, many of the public structures you'll find getting damaged or dilapidated after 25-30 years. So there we have to bring in the application of steel, and that is why we are making this kind of workshop to create a kind of awareness, to create some kind of beginning, that people must understand the role of steel, and they should know also how to gain some kind of knowledge and expertise about steel design. As an institute, we are doing our small training programs, we are doing workshops, we are making papers, we are doing studies. Right now, we are doing a study with IIT Bombay on LCC, because government departments do not accept LCC as mandatory. They believe that if you bring in LCC concept, then perhaps the L1 price, which they are otherwise getting through tendering, that gets disturbed, because when we understand their predicament, because the approving authority is worried about the cost aspect, initial cost aspect. He is not bothered about the durability of the structure or the life of the structure. So we are trying to bring through some kind of study, some kind of data, some kind of reports through IIT Bombay, how LCC consideration can be made mandatory in government tendering process. That is what we are trying to do, and the project is funded also by Government of India, by INSDAG and Construct Steel. And we believe that once the report comes out, and if the government accepts it, it is going to do a great job by making the project owners understand the various merits and demerits of alternative options: concrete, steel, steel composite. All the options can be understood, and that is the kind of small job that we are doing. We are doing number of training programs on various contemporary topics. You can have a look at our training programs, and whenever you find usefulness, you can participate also. You can even suggest what kind of topics that INSTAG should take up in our training programs, in our workshops. We are participating with we are having patronage from various IITs: Bombay, Chennai, Madras, this Hyderabad, IIT Roorkee. In fact, we are doing a lot of work with IIT Roorkee. They are right now making a teaching resource materials for architects, because architects demanded that there is no composite book where knowledge of steel application is available for architects in their language. So now we are trying to make a teaching resource materials for teachers of architecture as well as students of architecture, with the help of IIT Roorkee. That will be coming out next 3-4 months time. We are already having a good teaching resource materials for structural engineers, which is available in our website. This was earlier made by IIT Madras, now recently updated with help of IIT Hyderabad. You can have a look. That gives a complete picture of all that is A to Z of steel design. And that book is really helping a lot of faculties as well as professionals. We have got the feedbacks, and that is also selling well. So these are the small efforts that we are doing, and our executive council, of which Dr. Abhay Gupta is a member, whatever guidance they are giving from time to time, we are doing. But whatever job we are doing, they are very, very small and minuscule. We want to enhance our scope of work. We want to get your feedbacks how we can make ourselves useful to the community, community of steel and civil and structural engineers who are interested to work in steel. And once you get your ideas, your feedbacks from time to time, that will be a big help. INSTAG is a not-for-profit organization. We are not doing any job for making commercial benefits. It is only to create awareness and provide, enhance the knowledge base of the professionals in steel. That is what we are doing. Thank you. Thanks for your time and attention.
Thank you, sir, for the address and for your continued support in promoting steel-based construction. Now, I would like to invite Mr. Muneeb Mehraj, who is the Assistant Manager in INSTAG, to present an overview of the INSTAG and its key initiatives.
Hello.
Hello. Yeah, good morning, everyone. So, am I audible at the back? Am I audible? Yeah. So I'll be very brief because we are already running out of time. So first of all, thank you all of you, thank you Indore for coming, and it's a lot of INSDAG members, a lot of people from Acropolis, SGS, ITS, IIT Indore are coming. So it's an honor to have you all of you here. To our patrons, SAIL, so people from SAIL would be coming, and to Tata Steel, we have people from PAG Group, I think from PAG and marketing and sales. So it's good to have you here, sir. And of course, to IIT Indore, Professor Sandeep Chaudhary, Professor Pavan, so they have been instrumental, and to our EC member Abhay Gupta, Professor Dr. Jay Jain, and also to Ashutosh Kutumble, sir. Thank you so much, sir. So I'll be very brief in taking out Mr. Mishra. DG INSDAG already took you through what we do and the overall activities. So I'll be very brief in what we do based on the activities. So we are formed in 1996 by Ministry of Steel and all the major steel producers of the country. We started functioning in the year 1999. Then these are members. We have our members other than our founding members are all the, we have Larsen and Toubro, we have Kirby, we have Tata Consulting Engineers, we have CBRI, we have IIT Indore. So these are all of our members other than the founding members. What are our activities? So basically, the main activity that we have, we do trainings and dissemination. We do seminars and workshops. But other than that, we are also coordinating with BIS and IRC for advancing steel-related standards. We are also doing promotion of steel-based construction through webinars. And also, we are doing some sectoral studies as well. And also, as sir told, we are doing some books, resources like TRM, which is like selling like anything, and people are actually finding it really useful. Other than that, we have identified 3 areas. One is steel concrete composite, one is green steel buildings, and one is LGSF. As we go forward, we are gaining expertise in these 3 areas. So as sir was talking about, this is one of our main primary study that we are doing with IIT Bombay. So this is on LCC, that is life cycle costing. So as sir said, at the moment, there's no provision where we can find out if... Yes. Okay, sir, I'll be fast. Yes. So this was one study that we did. This was steel consumption study for commercial buildings. We collected data of 43 buildings across the country to find out the consumption of steel. Then we recently did one study on landmark steel structures. Here we collected data of around 10 structures throughout the country. And this document was compiled and this was circulated to our members. And we got good testimonials from, in fact, Mr. Abhay Gupta, CEO and Managing Director of Tata Steel, TV Narendra, and also Mr. Atul Bobe. Then we have done some studies for SAIL. We did one study on MLCP. We have done one study on steel crash barriers, and we did one study on DI pipes. For Tata Steel, we are associated with a lot of projects, but one which was recently in the zero energy building that came up in Bhubaneswar, we played a role by partially funding and also project monitoring. Other than that, in the Construct Steel are the global awards. They actually give awards to top projects throughout the world. So we are the INSDAG. INSDAG is the India partner for that, and we actually submitted the Tata Steel's TMH Bokaro project and TPF Group's MG Setu in Bihar to Construct Steel. For our upcoming online training programs, for the first time, we are doing a program on AI. So this is on design, detailing, BIM and AI. So this is next month. And we are also doing one course on hollow sections. So these are online programs, open for all. We receive participations throughout the country. Other than that, one project, because some of you are designers, professionals are also joining. So we are doing one project on Indian road bridge projects. So where we'll be conducting interviews with bridge engineers, bridge designers and consultants to understand the market, to understand what is happening in the bridge industry. So this is one project where we'll be meeting all the consultants. And for a lot of faculty people are also here. So we are also enrolling experts for our training programs. So if any of you, maybe research scholars or faculty, if you feel you can give any lecture on steel, this is one form where you can fill and we'll get back to you, and you can be on this side and you can present to the audience. Other than that, this is for the students, and with this I'll wrap up. We're also I'll also be presenting on sustainability, but for one of our projects on sustainability and LCA, we're also hiring interns. So if any of you is interested, we'll be glad. It's a work from home opportunity, it's paid. So we'll be glad to have you in our team. With this, thank you so much, and you can scan this for our website as well. Yeah.
Thank you, sir. I request Professor Chaudhary, sir, to please present the memento to Mr. Munib Maharaj.
ये 11:45 तुम बाहर जाएंगे गाड़ी रख
Thank you, sir. Now to highlight the objectives and technical focus of today's seminar, I request Professor Sandeep Chaudhary, who is the convener of today's seminar, to provide an overview.
A very good morning to the dignitaries on the dais and Director General Mishra Saab from INSDAG. I would not be able to take so many names because there are so many eminent persons here. And I'm seeing like Professor Bhatia, he is teacher of some students here. So you can see we have from BTech second year students to so eminent persons. INSDAG, on a personal front, I have been following INSDAG for more than 1 decade. And as DG Saab was telling, INSDAG is doing a great job, because if you see, there are two types of construction, mostly concrete, steel, and of course steel, concrete, composite construction, which I will be talking today. In concrete, we get a lot of literature, books, a lot of experts, and there is a complete, like you can say, series of activities which are going over the years, and you have a complete list of domain experts, starting from BTech students to consultants who have long experience. But when it comes down to steel, there are still a lot of challenges. It starts from good literature. There are many missing links in the literature. We have less experts. In academia also, one of the reasons is to test concrete and to do studies on concrete is easier than doing studies on steel. If you have to test steel, you need to have a lot of big load frames, big actuators, and big facilities, which many institutes still do not have. So overall, this is leading to somewhere a vacuum where we find very less experts in the field of steel structure, and students also at times don't get interested much in steel structures. But we know that the future is of steel and it has immense potential. We can see the developed nations, they're already working on this. The majority of the structures are steel structures. So when INSDAG contacted us, we thought that yes, we should grab this opportunity to bring all the experts, students, faculty members together on one platform, so that we can work upon, we can discuss what is missing and how to fill that gap. So I hope this seminar will be useful for all of you, all the participants. And please go through the INSDAG publications also, because I have been using INSDAG publications for teaching also, for my own understanding also, for more than 1 decade, as I told earlier. I was discussing with Munib also, we have found out some places where these publications, they can be improved, because things are changing very fast, codes are changing very fast. So we intend to work on those aspects also. So thanks, everybody, again.
Thank you, sir, for setting the context of today's technical sessions. I now invite Dr. Gaurav Sil, sir, who is head of the Department of Civil Engineering, IIT Indore, to present an overview of the departmental activities.
Thank you, Astha. Uh, First of all, respected dignitaries on the dais and all the participants, our faculty members, staff, and students, a very good morning to all of you. So, it gives me immense pleasure to welcome you in IIT Indore for this very interesting and exciting topic on seminar topic on reimagining construction paradigms in steel for the next generation. We are delighted to organize this seminar in collaboration with Institute of Steel Development and Growth. Their efforts, INSDAG efforts, are significant throughout the country for coming up with well-defined or nourishing the steel-oriented infrastructure in the futures and coming up with the innovative practice in the using the steel. Now, just coming up to the to give some overview of our department. The Department of Civil Engineering has established in 2016. So this year we'll be celebrating 10 years of this department. Since then, last 10 years, we have been growing gradually. So coming through the few numbers, we'd like to say that currently we have 17 faculty members with diverse expertise, particularly in rich 5 domain. One is structural engineering, geotechnical engineering, water resources engineering, environmental engineering, and transportation engineering. All of our faculty members had represented nationally and internationally many international conferences, as well as editor and editorial board member, as well as they have received many awards, Indian awards, as well as awards globally. Similarly, at the same time, our students, especially our PhD scholar, they are also put a significant effort to establish or renown our research activities throughout the national and international domain. So, as I mentioned, we have particularly labs in transportation engineering, structural engineering. These are the UG and PG lab, as well as we have water resource engineering, environmental engineering, PG lab. And to emphasize, I would like to say we have some interesting research lab like impact lab, brick lab, our environment, this geotechnical hazard lab, traffic engineering lab. These are also there. One thing to emphasize, so out of this lab we would like to mention, I would like to mention that a notable milestone that has been achieved successfully, we have transferred technology from our brick laboratory for making it a departmental first step to have an impactful translational research, and we transfer this technology to the society. Coming to the programs, we have our undergraduate program. We provide BTech degree in civil engineering. We currently running 2 master's program. One is Master's in Water, Climate and Sustainability, Master in Structural Engineering. And from this year onwards, 2026, we are going to start Master program in Transportation Systems Engineering and Master in Geotechnical Engineering. So currently about 55 students per year we are graduating for undergraduate students, 20 students in PG students, and many PhD scholars. So some of the research area I would like to emphasize here, like green and sustainable construction materials, climate change and hydrological extremes, landslide hazard assessment and early warning systems, solid waste management, traffic engineering and management, road safety, and disaster resilient infrastructure. These are few to emphasize. The department has also embraced emerging tools such as machine learning, remote sensing, high performance computing, advanced theoretical modeling to strengthen the both fundamental and applied research. At IIT Indore, Department of Civil Engineering, we remain firmly committed to advancing the research, education in academic as well as research field to areas of infrastructural engineering. Such events, what we are having to the seminar, align closely with the department vision of promoting sustainable, innovative, and industry-relevant engineering solutions while preparing our student to take leadership roles in the next generation of infrastructure development. So coming to the last part, I would like to say once again, I would like to uh, warm welcome you, all of you, and sincerely thank you for your valuable time and support. I also express my gratitude to the INSDAG for their collaboration and organizing this impactful seminar, which will be really beneficial to our students, researchers, and all the participants who were over there. With these words, once again, I welcome you, all of you. Wish you a great seminar success ahead, and I hope you will enjoy all the series of lectures and panel discussion over here. Thank you. Thank you so much.
Thank you, sir. I request Mr. Munib, sir, to please present the memento to Dr. Gaurav Sil, sir.
एक नई लिंक प्रोवाइड कर देंगे।
Thank you, sir. I now request Professor Abhirup Datta, who is Dean of Research and Development at IIT Indore, and the guest of honor of today's event, to share a brief note on the institute and its R&D activities.
Thank you. Good morning, everyone. Glad to be here. Welcome all of you to IIT Indore. I can share a brief note about the institute. I mean, we are fairly new. I mean, still in the teens. It has been we have come into being in 2009, but what happened is we stressed the emphasis on publications and research very strongly. Apart from being a diverse institute with several departments, several interdisciplinary departments of what I come from, space engineering department, biomedical, biosciences department, and now recently this sustainability department has come up, and with other centers focusing on Center of Rural Development, futuristic space and defense technology, etc., etc. So our interdisciplinary research has been a forte on the institute, which has really paid off very well. Of late, under the guidance of our current director, Professor Joshi, we have established something called Center for Translational Research. So you heard Dr. Gaurav Sil telling about this translation of this bilayered bricks and Gobear from Professor Sandeep Chaudhary actually, which actually happened because of these initiatives which are created. Certain other things we have also streamlined, which has actually helped. One is helping in patent filing, as well as announcing this translational research fellow, under which you can retain your the PhD student who has come up with something, can actually stay back for one more year as a early postdoctoral researcher, and to finish the job of either filing the patent or translating the whole thing to the company and then move on, so that the IP stays with us as well as the work gets completed, not gets halfway done and somewhat thwarted. So these tapes and many more to come. I mean, there are many more discussions can happen across this. Today's there is a panelist discussion, I guess. I think is there. So I would encourage you to not only attend to this particular seminar, but also to look around the campus. It's a beautiful campus we have, and visit the labs we have, which Gaurav already mentioned that in civil department, but also other departments. If you like, we can show you around. And once again, thanks for being here. Welcome to IIT Indore. Enjoy today.
Thank you, sir. I request Dr. Gaurav Sil, sir, to please present the memento to Professor Abhirup Datta, sir. Thank you, sir. Now, to conclude the inaugural session, I now invite Dr. Pawan Kankar, sir, who is also. Okay. No, no, no. Okay. Uh, it is my privilege to now invite our chief guest, who is also the EC member of INSDAG, Dr. Abhay Gupta, who is director of Skeleton Consultants Private Limited. He's a distinguished structural engineering expert with over 30 years of experience, known for leading major industrial and building projects, pioneering India's first private wind engineering center at JUET Guna, and achieving accolades like Outstanding Structure of the Year Award for Natwara Shiva statue in 2024. We welcome you, sir.
Thank you, Asta. Good morning, young engineers, students from IIT and other academic institutions in Indore and around. And I see the academic faculty members from IIT and the other institutions here. I can see some of the eminent professional engineers sitting in the audience as participants who have come here to learn something or to add something to whatever knowledge they have already. They are doing good in their field, and eminent faculty members and administrators of IIT, including Director IIT, who has given all this opportunity. Then INSDAG, who has taken this wonderful initiative across the country to disseminate the knowledge. That is certainly with the support of the organizations like SAIL, Tata Steel, ArcelorMittal, and other steel producing companies, which are really doing good towards the promotion of the steel. Now, as has been spoken by almost everybody, in general, when I ask my students, what is the construction material? Out of 100 students, only 10 or 15 are able to tell that steel is also a construction material. Generally, we forget to see around us that there are steel structures, but otherwise we are surrounded by steel structures. So, my dear students, we need to change the perspective. We need to just look at the things around beyond the conventional concrete and the brick. Though I'm not saying that concrete is not a sustainable material, it is. But you need to work hard to make it more sustainable. You need to, while on the other hand, the steel is a more comfortable material to give you a sustainable construction. We have the eminent speakers lined up today, right from Jayesh Jain, Sandeep Chaudhary sir, Ashutosh, the young engineer who is doing a lot of good things here. We have INSDAG team who will be telling you about the life cycle costs and the bridges, and we have other SAIL faculty will also be there. So, my dear student, this is just a beginning for you. You already know about the steel, but this is going to connect you to a bigger platform in the steel construction in the country. So, just brush up your things, be in touch with everybody who is present here or to whom you are exposed. And as has been said, INSDAG membership, it is an excellent platform. I am a member of INSDAG since many years. I don't remember now how old it is. I used to preach to my students also. Some of my students are sitting in the audience. I can see. Yeah, Ashutosh is there and Deepthi is there. So even Pachani ji had been with us for long. Atul Pandey is sitting there. So we have been promoting that please be a member of INSDAG. And for students, I think, Munib, it's a free membership. You don't need to pay. You just need to register on INSDAG website. So connect there and you get a lot of literature from that website free. For faculty members, certainly you can pay some money. And practicing engineers, you should contribute to the INSDAG platform. And as has been said, you can also be on the other side of the platform delivering the. So whatever expertise you have gained, generally we are shy people. We do good thing, but we don't share. So my dear friends, I started my career in the engineering field in 1976 as a student of SGS ITS Indore. जो लोग नहीं जानते for them. And out of 76, now from 76 to 2026, which is 50 years almost. So Professor Bhatia is sitting there, my Guruji. He is just a young professor of 85 years of age. Sir, 85 kam to nahi bola. So with his energy and motivation, we all are doing so much of good work. I moved from here to Noida and I'm connected with INSDAG as an EC member. I'm just doing some little contribution to their good activities which are across the country. So I'm very happy to be here as a chief guest, though in Indore city I'm not a guest, I'm a host itself, but I'm thankful to INSDAG to the DG sir, Mishra Sahab, who has always been an appreciator of our good things. All the best to everybody sitting here. I would be here till the evening, not unlike other chief guests who would just go after the inauguration in IIT. I would be here. Please feel free to ask, interact, and gain more out of us. Thank you very much. All the very best.
Thank you, sir. I request Professor Pawan Kankar, sir, to present the memento to our chief guest. Thank you, sir. To conclude the inaugural session, I now invite Dr. Pawan Kankar, sir, who is also the convener of today's seminar, to deliver the vote of thanks.
A very good morning, and dignitaries on dais, dignitaries of the dais, Bhatia sir, Jayesh sir, Ashutosh sir, all the speakers, my faculty colleagues. I can see ma'am, Satya ma'am, and others, and our administrative support system here, Gupta sir, Parchania sir, Malik sir, all participants. I welcome you on the behalf of our team and IIT Indore. So on this occasion, I would like to sincerely thank our chief guest, Abhay Gupta sir, and guest of honor, Abhirup Datta sir. I think he left because of his commitment. My sincere thanks to the Gaurav Sil sir, who spared time in spite of his busy schedule and briefed us about the civil department and the activities going on. Then my sincere thanks to Jayesh sir, Ashutosh sir, and Munib sir, and Siddharth Chauhan sir, who are going to talk about so many technical aspects of the steel and how it can be useful for the as a construction material. So as our chief guest mentioned, that even sometimes we are unable to recognize that it is a construction material. So what is the importance and how we can improve further? So that will be discussed in future sessions. Our sincere thanks to Steel Authority of India Limited. We acknowledge them as a partner to the seminar with the INSDAG. So INSDAG and Steel Authority of India Limited both are our partners in this seminar. Our thanks to Mr. P.K. Mishra, DG INSDAG. Then I sincerely thank Professor Chaudhary also, who given us opportunity by conducting this seminar, and his leadership is guiding us and to us as well as the department and the institute as well. My thanks to a team of our support, Ms. Harsha, Praveen, and Nitin. These and other supporting staff, I may be forgetting some name. So they have arranged all the things in a better way. And I should not forget recognition of our student volunteers. They work day and night. They contributed a lot, made all the arrangements, planned everything. So my special thanks to the team, and particularly I would name some Akash, Astha, Gaurav, Bhavna, and I'm sorry if I'm forgetting some other name, but all student volunteers who contributed to the seminar. My sincere thanks to all the participants who spare time for joining today. I think it will be mutual benefit. We will be having sessions and try to make these sessions interactive, learn from each other. Thank you so much. Have a good day.
Thank you, sir. We now begin with our first technical session of the day. It is, yes. It is my privilege to introduce our first speaker, Engineer Jayesh Kumar Jain, who is the Director of Skeleton Consultants Private Limited, an organization with over 4 decades of professional excellence in architectural and structural consultancy across diverse industries and infrastructure sectors. He has also designed 500 plus water tanks and 100 plus water storage tanks, sewage treatment plants across the country, contributing extensively and resilient to the steel development. I now invite Mr. Jayesh sir for the first technical session of the day.
You have the pen. Okay. Whichever is okay. I have HDMI to the
No, sir. Please pen drive.
pen drive will be better.
We are going live. So that's
इसमें हाँ ये मुनीब सर के हैं मुनीब सर को दे दो। जी सर। थैंक यू सर। यस यस यस
Good morning, friends, distinguished guests, industry partners, consultants, faculty of IIT Indore, students, and let me acknowledge the presence of my guru, Dr. O.P. Bhatia here. With his blessings, I have been, doing the work in the society in a better way. So that is the, the teacher. When he teaches you nicely, you become someone who is able to do some good work and stand here and talk to you. I'll be starting my lecture with, I'll be devoting some slides on the theme of the seminar. I've been a consultant from 2007, but I was doing lot of real life projects with one of my senior who was already there in the field, and I was doing some work with him in the evening out of my interest. So with that experience, I've learned that what steel is all about, because in academic career, when I was doing, as a student, when I was learning, there was only one subject on steel structure. There were many on concrete technology, concrete structures, structural analysis, and so on and so forth. And when we were graduating, there were a lot of concrete structures around us. Seldom there were few steel structures, and even if you go into the industrial areas, there were typical truss-like structures we were looking at. So let us start with today's theme, that reimagining construction paradigms, steel for the next generation. Why we are thinking of changing our attitude towards the construction material from conventional one to steel. What is the reason? if you look today in Davos, the World Forum, the politicians, they are discussing on climatic changes, climatology. And if you look at this in Indian context, you will find that our AQI levels in various cities that is rising and rising to alarming levels. That means this alarming situation has to be tackled. And from our end, from constructors, what we can contribute, we should contribute. So sustainability is now a necessity. So what is a sustainable construction? What is a recyclable material that we have to discuss? The cities are expanding vertically as well as horizontally. Climate changes are alarming. We have a pressure to build faster, smarter, and greener. All the things are needed. Our cities are growing. Traditional construction methods, if you look at, if you talk of concrete, if you talk of masonry, then you will find that they are slow, labor intensive, and resource heavy. So we need a paradigm shift. And this shift has to happen in such a way that we can overcome all these points which I have elaborated. So if you look at all these points, it looks to me that steel will be the material for future. Now why? So for that, I have, in India, we are talking of steel right now. If you look at the construction in USA, right from 1930, their multi-storied buildings were in steel. And I could get certain photographs from NET and other sources, wherein you'll find that this is the steel building that is called Rockefeller, which was built in 1930. And you will find steel construction with the help of the joints are riveted joints, unlike our bolted joints today. We have Empire State Building, 1930 to 1933, is still standing tall today without any problem. 100 years have passed. So what we have is the construction which was there in USA 100 years ago. Now we have started talking about that. Although concrete was available in those days also, 1930, but steel construction was chosen. Why? Because of the fact that it was with a speed you can do it, the availability of steel with these producers of steel, they were pushing it. Thirdly, they were making it as a matter of pride that when you build such a strong and height, vertical height of say around 1300 feet buildings, you will be considered as the most modern country in the world. It was a matter of pride. The steel industry was pushing it. So though the initial cost was high, they could convince the builders, the constructors, that you can go with steel, complete your building in a very shorter span, sell it, earn profit. So if you look at this Empire State Building, it was constructed in a span of 13 months. height with antenna 1300 feet. That was the kind of construction which was happening in USA in 1930. And if you look at the US even today, most of the construction is happening in steel. Most of the construction is happening in steel. In European countries, it is around 50-50. But in US, it is still around 70-30 as a construction material. Now, why do we say that steel is there for the next generation? So, the first point is that you need sustainability of construction, sustainability of material. Whatever you are building today should become a raw material for tomorrow. So if you look at the steel, you'll find that it is sustainable material, then it is 100% recyclable. You can recycle it infinite times without losing its strength. Then we have now the different categories of steel. You are getting very high strength steel. So it will reduce your material consumption. Modular steel systems are there. Green steel being produced with the help of hydrogen instead of coal. So everything is green. And this is the need of the hour, because our environment, we are polluting it. Our AQI is increasing. We have to take care of that. Now, the second point, why we are going for steel and why we are advocating for steel, is speed of construction. You have prefabrication available now. You can prefabricate the components in the factory in a controlled environment, transport it at site, assemble it, and steel is a material which is lightweight material. If you look at the strength versus weight ratio, it is very high. So speed is one of the parameter which goes in favor of this material. Then there is a flexibility. You have a design freedom. Architects would like it. Why? Because it's a slick element. Its strength to weight ratio is very high. Complex geometries can be made out of it. So it's a choice of architects as well. Adaptability. Structures can be modified, expanded, retrofitted more easily rather than the concrete structures. Integration with technology, that's a very important point. Steel meshes well with modern digital tools like BIM. You can create a digital twin. I'll elaborate more on this, that how do you create a digital twin in steel. And you can, you can really look at the life cycle of the steel with the digital twin. With time, you can monitor it. Then it is resilience. It is a resilient material. It's a resilient material. Durability. Now, when I say durability, you might be questioning that the durability, if you talk of durability aspect, what about corrosion? What about fire? What about fatigue? But the durability comes with certain coatings. If you do certain coatings, if you maintain them properly, it is going to be a durable material. Structural performance, that's a very important point. If you look at the seismic loads, now since steel is a ductile material, If you look at the hysteresis curve of steel, you'll find that it can absorb lot of energy when it goes into the plastic zone. And let me tell you that how I look at the seismic loads, it is the energy which is getting transferred to the structure, and how that energy is absorbed by the structure becomes very, very important. So how that energy gets utilized in the structure, in what way it is done, that becomes very, very important. And steel is a material which is a ductile material which can absorb a lot of energy without cracks. It's not a brittle material. Then sustainability, 100% recyclable without any loss of properties. So this supports your circular economy goal. That means what I said is that whatever you are building today, with whatever material you are doing it, it should become the material, raw material for future constructions. That is what is important. Then I was talking about the digital twin. So digital transformation is taking place in the industry with the AI tools which are available. Now, one of the tool is BIM, Building Information Modeling. Now, steel is a material which can be precisely cut into, millimeters of, precision, millimeters of precision. Then you have digital twins, enabling real-time monitoring. You can do that in steel quite easily. You can measure strains, you can measure temperature, you can measure if there is rusting taking place, you can measure fatigue, you can measure vibrations, and with those chips installed or embedded on the steel structure, this data can be transferred to the real time to a computer, central computer, and you can create another replica of the present structure. So that is what is important. And with the help of AI tools, you can really look at if there are problems being created inside the structure. So you get a warning. You can tackle the problem well in time. Or you can tell that, okay, if this is the progress of rusting, if this is the way the strains are changing, then whether my structure is safe or how much it is going to last. So steel scores big on traditional construction. I've given you certain points. I've discussed some of them. I'll skip this afterwards. Now, traditional construction versus steel construction, if you compare them, so you have heavy reliance on concrete, Now, if you talk of next generation steel construction, it is a smart mix of steel plus concrete. Now, earlier days when we were talking of concrete structures, what we used to do is that concrete is strong in compression, weak in tension. So we used to blend concrete with tension reinforcement bars. Now it is reversing. Steel is there and we are using concrete in compression so that we get advantage of that compression. Though the steel is as strong in compression as in tension. However, because of the slenderness of the members of steel, if you put concrete on the top in compression, it will avoid buckling issues. both lateral torsional buckling as well as overall buckling phenomena. So now we are putting concrete on steel. Then if you talk of traditional construction, next point is longer build times. It takes quite long to build things. It is faster assembly, prefabricated steel. Here it is limited recyclability. Steel is 100% recyclable. Here it is bulkier designs. They are sleek, lightweight, aesthetic structures. Then sustainability is a problem with concrete. These materials durable and sustainable. So if you look at the seismic aspect of it, you'll find several points over which the steel structures score over concrete. Now, if you look at the shape of the hysteresis curve, you'll find that the RCC structure has narrower loops, pinching effects due to cracking and bond slip. It doesn't happen in steel. It's wide loops. It absorbs a lot of energy because of wide loops, minimum pinching. So that's one part. Then energy dissipation, that is very, very important, that how much energy you are supplying to the structure and how it gets used up, so that your structure remains safe, and after the absorption of energy, the strength doesn't degrade. That is what is important. If you look at concrete, under the earthquake forces, it will crack, bond slip is going to take place, and with this cracking, its strength and stiffness both will degrade. Whereas in steel, you'll find that it's nice yielding of material, no brittle failure, and the strength degradation is minimal. So you can look at these points about steel again. Ductility is one of the points which I have talked about. Residual strength, which is very less in concrete, and after many cycles, the steel has lot of load carrying capacity even after that. So these are all, and these were the hysteresis curve I was talking about. Look at the curve on this side, that is this curve, which is for steel. And if you look at the loops after every cycle, it absorbs lot of energy, more and more energy with each cycle, and is still maintaining the strength and stiffness. Whereas the other curve is of concrete, you will find that with every cycle, the strength degrades, the stiffness degrades. Now, what are the challenges in use of steel? All good points, but there are certain challenges. The first challenge is the cost. Initial cost is very high as compared to traditional construction. Second point is corrosion. So root cause is that steel reacts with moisture, salts, pollutants. Mitigation, how to mitigate this challenge? You have to have anti-corrosive primers, galvanization, and regular maintenance. Cost impact of mitigating that effect is high. Life cycle cost is high. Inspection, recoating is to be done. You cannot leave it for the lifetime without recoating it. In Indian context, we have aggressive coastal and industrial environment. Every city is getting polluted now. Now there are regulatory challenges. Mandatory corrosion standards, they are not there. Maintenance. coatings and health monitoring. Once you handed over the building to the occupants, who is going to maintain them? And we know the maintenance is very poor in our country. Even if you have that digital twin, who is going to look after the data afterwards? That is the problem that is still has to be solved. Fire safety. What about the fire safety? You know that steel, it becomes, almost, it will go to the softening points at around 400 and beyond. So once it reaches to that point, it will soften up 400, 500 degrees Celsius and won't give you a lot of time before you escape out of the building. Unless and until you're done into cement coatings, vermiculite plaster, or you use certain fireboards to protect the steel structure properly. And you know the cost impact of these coatings is very high. Almost, if you do an intruscent coating, then you will find that the cost of the structure itself will go up by around 25 to 30%. So already the cost of steel structure is high, and then adding to that, if you do the intruscent coatings, another 25 to 30% cost. So it's a very high initial cost. Then in Indian context, if you look about, as the sir was also telling, that limited fire engineering expertise. You don't have any special topic or subject in our curriculum which talks about the fire engineering in steel structure. How it affects steel, how to protect it, all those things. And then again, there are regulatory challenges. They are evolving. People are recognizing the problems like INSDAG. They're doing a lot of work in which these regulatory, challenges are to be overcome. So now there is next generation steel is now coming up. People are, busy doing research on ultra lightweight steel for high-rise construction. There are fire-resistant and corrosion-resistant alloys. They are mixing it with it so that the temperature at which the softening is taking place is raised beyond 400 degrees centigrade. Then hybrid steel composite system. Chaudhary sir is going to talk about that you have a concrete steel composite wherein you will find that if the top surface is of concrete, that surface is taken care of for the fire. The surface below you have to treat. So you have the requirement of fire coatings will substantially reduce. The cost will reduce because you will take advantage of the concrete, its properties in compression and steel in tension. Taken together will economize the structure. Then you have smart steel embedded with sensors that talk to us. Though in India it's really very tough right now because you don't have people to monitor the sensors, the progress, and you will have to employ AI tools so that it does that monitoring in real-time framework. This was I was talking about the new steel which is going to come up. Already a steel is there which can perform better in case of the temperature rise. Now this is the intruscent coating. You will see how that coating works. So it is the new evolving steel to handle these challenges. let's skip it. Then modern high-rise construction, which will balance the modern steel and concrete. Chaudhary sir is going to talk about this in the next lecture. I think we have now concrete cores, which takes care of seismic resistance, and then you have the steel on the outside of the structure. Then you have composite floor systems, you have concrete slabs on the steel beams, and so on. You have high strength concrete available, 80 to 100 MPa is possible now. And cast and fireproofing now balances, because some of these surfaces will have concrete, so you need not do any coating there. It itself becomes, fire resistant, and so on. This is the concrete core, and this is the composite construction. Now I'll come to my own topic of aesthetics and structural innovations. How much time is left? Okay, I'll quickly go through that. So aesthetics and structural innovations. So like I said, in 1983, when I got graduated, all about steel I was knowing is that you have trusses. You have trussed structure over either the concrete columns, or you have steel columns and trusses on it. That was what was my understanding about steel at that time. And if you look at when you are moving through the cities, it was all concrete. When you are moving to a industrial area, you will find all industrial structures, same shape, same roofing material at that time, either asbestos cement sheet or the steel sheets. That's it. And they are of same color. If you have AC sheet, white. If you have metal sheet, gray. So if you are passing through a sector, if you look at this kind of structure, you can certainly say you are in an industrial area. No architecture, very boring. So it was a kind of, the construction in steel industries at that time. Now there was no option in industries. You have to use steel only. The reason being that you have large spans. You have to leave a lot of column-free spaces in between so that material movement takes place. You can have machine foundations. So functionality becomes very, very important. So you have larger spans. In larger spans, a material which gives you a better economy is steel. Because the weight of the roofing is negligible. So if you look at that ratio, you'll find you can't have a material which gives you a more self-weight than rather the weight it has to carry. So that's why it is only steel, no choice. So that was happening in those days. So you'll find that pre-1995, you have brick walls, steel wooden trusses, asbestos or steel corrugated sheets. Fire and corrosion concerns was there. High corrosion risk was there. If you have metal sheets, they were non-galvanized at that time. 1995 to 2005, of course, you were getting certain galvanized sheets. Better ventilation was taking place. Improved corrosion resistance because it was galvanized. And then after 2005, we started getting pre-engineered buildings and FRP roofings, better corrosion resistant sheets. So these were the typical truss configurations in those days. And these were the trusses which were having in those days. And if you look at the transformation 1940 to 1970, these were the typical industrial buildings. Same. Then 1960 to 1973, these were the buildings with roof sheet, which is metal sheets. Then 1970 to 1990, almost you were looking at this kind of, industrial structures. And then 1997 onwards, the scenario started changing. And the scenario started changing because we were getting color-coated sheets, metal sheets. And I'll tell you a very interesting thing, that before 2000, the architects, were not, very much interested in working with a consultant who is in the field of industrial engineering. They said, what we have to do in an industry? I have no choice of color. I have no choice of how the structure is going to look like. You can have either a triangular shape or you can have a lean-to type of roof. And that's it. What is my role? You cannot play with anything. And then we started getting color-coated sheets in 1997. And then we started doing some experiment on the structure as well as architecture. So the first project, which was slightly different than what we did before, was that we have done a press shop for Caparo Engineering. It was done in 2001. So here, we find that we have changed the shape altogether. It was not looking like an industry. We have, the architect suggested that this is the shape I want. Can you do it? Because they will come to me and they'll say, oh, can you do it? Because they've been doing those typical constructions before. And then we said, yes, why not? We can do it. And then what we have done is that this was the configuration in which you have N girders, and there was the support for the north light trusses. And those north light trusses were also, hidden inside the sheets. The only challenge was that when you are designing a column, and I am now throwing the sheets out of the column outside surface. So there is a problem which is typically we call it as lateral torsional buckling to the column. Why? Because I am not able to support the flange. Purlins to the sheets in other structures, they are very close to the column, tying it up. That was not happening here. So we have to provide a column which was slightly more from the strength point of view, from the weight point of view. But for the sake of the architectural and the client's need, that I need a very good structure. It should not look like an industry. So that was the configuration. If you look at the sections, then the same client, then he said, okay, you've done a good structure last time, and I want that other structure is to be done. Now, again, the shape is circular on the top side. It was a Caparo long member. So what was the challenge here? I'll tell you. Now we have to, the truss which you see is the outside line is here. The sheeting has to go like this. So purlins cannot be here. purlins are to be here. What to do? So we propose certain brackets here of variable depth on that purlins were supported. But that is not all. Once you do that, the truss members, they are losing support in the lateral direction. So their effective length increases by so many times. Why? Because earlier the purlins were supporting this member at every node. Now that support is not available. So these members need to have more moment of inertia in the lateral direction. So we have spaced that member in the lateral direction so that we can bring the RXX value equal to RYY value. So this was the detailing. Then this is the structure under fabrication, erection. Then we have done certain other structures. I will quickly go through them. Now this is the structure I am showing not just because it's architecturally very nice, but this is the structure I am showing because, you know, say in 2000 or 2001, lot of PB companies started coming. And they were meeting the clients as well as the builders and the industrialists, saying them, you are going for a very uneconomical structure. Why do you want to go with trusses? I'll give you a factory product which will be much cheaper than this structure. And they were correct. In trussed structure, you cannot vary the moment of inertia much. If you want an economical truss, its lever arm should follow the bending moment diagram. Since we were not able to do it in trusses, so we could not economize. So they were saying that, okay, we do it. And we were still complacent about what we were doing, how they can do it, how they are going to have a, lateral support to the beam so that they can, in wind condition, they can avoid lateral torsional buckling. But when we came across their system, they were beautifully dealing with the bending moment diagram. Why? Because they were having tapered section. They were beautifully dealing with the lateral torsional buckling problem in the beam. Why? Because they were having flange bracings. They were beautifully dealing with another problem, that our trusses were mostly having a pin support near the support points. So it was almost like a simply supported truss. So in their system, the rigidity they could provide near the support, that has made the bending moment diagram almost even. So they could save material there also. And added to this, there was an advantage that it's a factory made product. Give a nut bolt system. The work which we were supposed to do in 9 months, they were completing it in 3 months with all good quality control. So this was the first project in which the client asked us that why don't you want to go to PV? And then we said, okay, let us do it. And we have checked the design of PV in those days. And then we started doing that. Now, the challenges we faced at the time when the first PV construction we were handling is that these people were doing it either with the American code or an MBMA practice guideline. And they were doing two very important parameters which this was missed. And that was that they were doing it with rod bracing. These cross bracings here, they're all rod bracings. The L by R ratio was typically crossing sometimes 1000. Of course, they were tension only bracings. But the American code used to say that this bracing has to be pre-tensioned, one thing. And secondly, you have to provide a turn and buckle arrangement so that with time you can give it a tightness so that it remains straight. And that was not happening in Indian context. No PEB vendor was doing that. And you know that if this bracing here, now suppose there is a sag in this bracing. Why? Because 9 meter of length, 32 mm diameter or 25 mm diameter, you cannot put it right straight without pre-tensioning. Not possible. So it is already in a sagged condition. Wind comes from this direction and the other bracing which has to come into effect because it will come in tension will take some time before it gets straight. So by that time the support to the column is already lost. Gable column support is not there until that tie member comes in tension. So first it will take time to straighten up and then it will start taking tension. By that time your column forces will not be the same as you imagined. It will become more or less like a cantilever than a propped cantilever. So that was the problem we detected initially. And then the portal bracings again. Now portal bracings cannot be the same as cross bracings. Strength wise they can be same. That's not a problem. But the deflection, and deflection becomes important when you want to give support to your gable columns. Then there are certain other structures which we have done architecturally and structurally. They are here. Unlike regular your shade structures, with sheeting and all, inside view, one of the projects which we have done right now, and this is one of the projects which our Delhi team has done, that is Gurudwara Rakabganj Sahib, wherein we have two domes, one over another, and used steel tubes in this structure.
Inside an existing building.
Existing building, yes.
We cut the entire RCC slab on the top, then inserted the top dome and then the inner dome.
Then it is the bungee jumping tower he must have talked about in some of his slides before.
India's tallest bungee jumping
Yeah.
facility.
And then this is one of the construction which we have done. Sorry. In Indore. It was a marriage garden. So if you look at, it looks like this. Look at the shape here. All these inclined columns at around 35-degree inclination. Initially, we thought that we will be going with self-compacting concrete in RCC columns because it will be difficult to compact it at such a slope. But then, in those days, there was no agency in RMC ready to give us self-compacting concrete with guarantee. And we failed in one of our attempts in our previous building that we were not able to get the self-compacting concrete properly. In fact, there was a lot of segregation taking place. And the slurry was rising on the top, having cracks. We rejected. And then he said, no, we cannot give you self-compacting concrete, forget it. So then we thought that let's go with steel construction because the shape is such that we will be able to, make it in a factory, assemble it at site with nut bolt construction. And we chose one of the PB vendor and asked them that, can you do it? They said, we can do it, but our design team right now is most of the times is doing certain typical structures, typical industrial structures of a typical shape. So why can't you do one thing? You provide us the design and we will do it on a tonnage basis. And we designed this building. And if you look at the skeleton which was created, and this is the inside view with a deck slab. And this is the certain photographs during the erection stage, how erection was carried out. So look at the erection stage, how much challenging it would have been. Yeah. So these are the constructional details. You will see the joints and you will find these are the joints. Typically the connection was flush end plate connections. Though, let me tell you that American codes, as per American codes, these connections do not qualify seismically a qualified connection. But since at the time the building was in zone 2, we used R equal to 3, so we were not needing those kind of connections. But this was the requirement of the architect that I don't want something projecting out of the wing. So we have to go for a flush connection. But remember one thing, that they are not qualified seismic resistant connections. However, since it was in zone 2, we used R equal to 3, we could do it. This were the various connection details. Then there was a tier, nothing architecturally so good about it, but structurally again, by using bracings at 27-meter height industrial shade, and since it was very slender, as a structure it was very slender, so every PB vendor, they quoted very high. And then we said, no, it can be economized by using bracings. So we have used bracings which was some out-of-the-box things for PB vendors, that how the bracings can be done in both the directions, and then we can economize on it. And this was a PDD office building which we did in 3 months' time for Aisha in a PB kind of a construction. Okay, so sorry. I'll go to the next slide, then we'll finish. Mm. Last acknowledgement. Thank you. No, this is the last, and then over here. Yeah. So, what's that? We gratefully acknowledge the support of INSDAG and IIT Indore for organizing this seminar and providing a platform for academic exchange. As a team of Skeleton, I really very much thankful to both IIT Indore and INSDAG. Then I wish to express my heartfelt gratitude to my alma mater and professor who guided me during my student years. Their dedication instilled in me the ability to ask why, understand what, and explore how, the very essence of engineering science. Significant information in this presentation has been obtained from various books, research papers across the globe and internet. I sincerely acknowledge the contribution of all known and unknown friends. I sincerely thank the organizers, faculty, and participants for their commendable effort in advancing engineering knowledge through this seminar and from providing platform that fosters meaningful exchange and learning. Thank you very much. And if time permits, we can take certain questions.
Yes, sir. If anybody has any question, they may ask. We'll also have a panel discussion in the evening. Any question? I request Professor Sandeep Chaudhary, sir, to present the memento to Mr. Jayesh, sir. Thank you, sir, for an insightful session.
Thank you very much. Thank you.
Now we'll have a tea break for 15 minutes. Refreshments have been arranged outside the seminar hall. Everybody is please requested to return within 15 minutes.
Just a moment, please.
Yes. There'll be a group photograph first in front of the library, LRC. Please head over there, please. Thank you. Thank you. आगे कर लो उसमें ना अपने को लगेगी इस वाले को कॉपी करके इसमें डेस्कटॉप पे एक फोल्डर बनाए इंस्टैग करके हाँ यहाँ पे इंस्टैग सेमिनार में हाँ इधर पे पेस्ट कर दीजिए अब इस पर संदीप सर ने अपने दी नहीं है
सबसे ले लो इसमें रखना पड़ेगा क्योंकि लाइव इसी से हो रहा है ना
हाँ हाँ ठीक है
Hello.
पॉलिश देती हूँ वो जो हाँ वो नीचे ठीक है मैं दे देती हूँ उनको हाँ हाँ ठीक है आएंगे तब दे देंगे हाँ मैं सर से बोलती हूँ संदीप सर का है वो भैया आप तो लो चाय कॉफी वगैरह ये यूएसबी है ना कौन सी वाली है हाँ यही है ना उसी में कर दूँ कॉपी दोनों कर दूँ क्या पता नहीं क्या चेंज है दोनों कर देती हूँ है ना हाँ हाँ कुछ कहे भैया?
कौन से? हाँ अभी हो रहा है, वो चालू नहीं था।
वहाँ पे हो गया कोच्चि में। अच्छा, हाँ था वहाँ पे पहले, अब कोच्चि में। वहाँ पे बेसिकली ज़्यादा करके काफी
ये वन वाली जो थी
फर्स्ट ना
हाँ, हाँ।
हाँ ठीक है
इंट्रोडक्शन
नहीं नहीं ठीक है जरूरत है क्या
SEAL team has joined us now.
कहाँ पे
ये टकराल से नहीं थी
अच्छा अच्छा
SEAL से।
ठीक है तो सर संदीप संदीप थोड़ा लेट हो गया सर
हाँ सर थोड़ा सा
थैंक यू सर अच्छा आप मुंबई से देख रहे हैं थैंक यू सर
coordinating this. Yes, yes. So बहुत बहुत धन्यवाद सर आपका।
Thank you, sir.
It will help us to reach out to people.
हाँ नहीं अच्छा है सर एक्चुअली हमें भी अच्छा लगा है बिकॉज इंस्टैग काफ़ी उनके पब्लिकेशंस वगैरह भी ऑल्सो कीप ऑन फॉलोइंग हाँ
सर लंच के बाद आपकी लाइब्रेरी पे विजिट कर सकते हैं।
हाँ हाँ कर सकते हैं
आप अनाउंस कर देंगे तो आपके
हाँ
पास
मैं
भी
कर
होगी,
देता हूँ
बहुत अच्छा
हाँ
है।
ठीक है ठीक है ठीक है
वॉलंटियर घुमा लाएंगे मतलब।
हाँ मैं बोल दूँगा ठीक है ये सेल से आया तुम्हारा फ्रेंड भी है ना सेल में था ना बात कर सकते हैं
दूसरी बात कर
नहीं ऐसे ही कि हमारा फ्रेंड है कि फ्रेंड है हमारा
क्या है
कि हमारा कॉमन फ्रेंड है
हाँ
कुछ आप दोगे ना यही है टकराल से ये प्रोफेसर पवन कांकर है मैकेनिकल से ये भी वन ऑफ द कोऑर्डिनेटर्स हैं इनके भी क्लोज फ्रेंड सेल में है सर Okay, good afternoon, and we'll now discuss about steel concrete composite construction. I have divided the presentation in two parts. The first presentation is a basic presentation, which is more inclined for the students because there are a number of students also here from bachelors, so that one can have a feel of what exactly steel concrete composite construction is. And in the second part, or second presentation, we'll be discussing about the codal provisions which are there as of now in our country and the challenges which we face in academia in dealing with those codal provisions. And I understand that experts from the industry, they also might be facing the same challenges. And there are some missing links actually, which are hampering the actual use of composite construction in the industry. So we'll be discussing a little bit about that. So we know composite construction, as Jayesh Jain Saab has already stated, there is speed of construction, flexibility, service integration, quality. And we talk about this composite construction, then as a civil engineer or as a mechanical engineer, we know there is a composite material also, but here we are talking about the composite construction, where individually steel is also a structural element and concrete is also a structural element. And it has a lot of advantages. So this is a typical steel concrete composite construction basically, which is used in the residential buildings or malls or industrial structures. We do have a steel girder and profiled sheet and a concrete slab, and concrete slab is connected to the steel girder through shear studs. And this is how we can see it is a composite steel deck, shear connectors. And of course, these stud shear connectors, they are called shear connectors because they're essentially taking shear. If they'll not be in action, then the steel and concrete, they will work differently and will have different deflections. Just to have a brief idea, like if we take second moment of area of the steel section which we use individually or concrete section which we use individually, or if we take it a composite action, then the second moment of area of composite action is 3 to 4 times. So this is the strength of the composite action. And you will see that mostly the concrete is placed at the top, and the reason is simple because mostly it is for those beams which are in sagging. So there we have tension at the bottom side, there we use steel. Top we have compression, so we use the concrete there. And as Jensa was telling, though steel is good in compression also, but then it takes care of that buckling issue if we put the concrete slab there. These are actual site photographs. You can see the shear connectors are placed here, very closely spaced. We have discussed the advantages. This is also another interesting thing, composite metal decking. So you'll see some embossments here, deformed ribs are there. And these embossments, they help in a good bond between this sheet, this metal deck, and the concrete, which is poured over it. At times, this composite metal decking acts as a formwork also. So we do not need a separate formwork. That means we can have construction at multiple floor levels at the same time. This is non-composite metal decking. You will see here there are no embossments, etc. This is how they are installed. This is a typical shear connector, and its strength is much more than the conventional steel, almost 2 times. And mostly they are patented items. That is another challenge. We do not have ready-made such shear studs which are there in open market. Mostly the company which is most popular is Nelson. So these shear studs are there and they have a specific purpose. So our Indian Standard Code also states a lot about these shear connectors. We'll be discussing about that. The sizes are within a range, and you'll see there's a head over these studs. And the purpose of this head is it prevents the uplifting of concrete from the steel. So whenever we design the studs, we have to design for the diameter, the height, the size of the head, the height of the head, and the spacing of the studs, etc. So these are actual photographs, and because it's a high strength steel, so our conventional welding machines don't work here. They are specific or dedicated welding guns which are used for these shear connectors. You can see here shear studs without deck. And again, there's an art of the placement of concrete on metal deck, because once we have said that we'll use metal deck as formwork, so we cannot abruptly place concrete on the metal deck because you have to take care of the deflections in this metal deck. And again, here in the design and particularly in the analysis, we have to take care that the analysis has to be in some parts, because initially when we are putting the loads and the section is not composite, so the entire load is coming just on the steel section. So there will be some permanent deformations in the steel section. And then once it is composite, it will have a higher second moment of area. So it will resist more load. But you have to take care of that construction stage also when it is not composite. At that time, only steel is there to take care of all the loads. So the load has also to be placed in stages. And this, we have to look for the construction joints, etc. also. Quality control, we have to weld, we can weld 2 sample studs, some bending tests are there, some pushover tests are also there. So before putting a lot of studs, we need to perform the quality control on these studs. And it's very important the scheduling of composite construction, like the deflection and other aspects. So we cannot go abruptly. We have to take care of what deflections will arise, what is the strength, how much composite action has been achieved at what point of time. It is more or less like if you recall what we do in the pre-stressed concrete design, we see different stages. So similarly here also we have to see different stages. This is another interesting part we do in steel structures also. There's cambering. So we can use the steel girders, cambered steel girders, because if we know that there is going to be a downward deflection, we can have an initial camber which is in the reverse direction, so that finally the deflection which we get is within the limits. Now this camber can be hot through a hot process or through a cold process. So both the processes are there. And you can see the markings. There are some marks here. These are of the markings of the camber when the processing was done. And then, of course, there are some disadvantages of cambering also, because they are for a specific deflection. So if you have calculated the deflections wrongly and if you have gone for a wrong camber, then it may have a reverse type of deflection also. Again, it's important when we need cambering. It can be on girder beam when there are members with uniform cross section, for filler beams, and for composite floor beams. When not to camber, that's more important when there are cantilevered beams or moment connected beams, because if there are moment connected beams, then they will cause additional moments when the cambering will be adjusted, and braced beams. This is heat cambering, so whatever signatures you have seen in the earlier slide, that was because of heat cambering. So here you apply heat at small wedge shaped areas, and this causes beam to be upside down. So that causes a deflection in this beam. So this is how the heat cambered beams are placed. You can see the marks of cambering here. So there, if you see in the earlier figure, the cambering is done here, and here it is put upside down. So the cambering was done on top and heat treatment was done on top, but here it is put on downward side because it has moved upward. And we can have cold cambering also. Of course, we need very high strength machines here. There's natural mill camber also, because if we are transporting it for a long distance, then there will be a natural mill camber. So that also needs to be taken care. And this is a typical drawing where the camber is marked, and you can see how the cambers are marked. So the amount of camber is indicated for each cambered beam. Like C equal to 3 by 4 inch indicates beam are cambered at 3 by 4 inch at the center. Same is 1 by 4. And of course, we have to have quality control. I will skip that part, and cost of cambering. Now, this is another, you can say, advancement in the composite structures. Now people are talking about the prefabricated concrete slab. So instead of casting the slab at the site, at some places people go with prefabricated concrete slab. The challenge is that if you are using prefabricated concrete slab, then we need to have studs also. So the design should be freezed at very early stage, because then these prefabricated slab, they should have spaces for these studs so that they fit over the studs. Else it will not be possible to put the prefabricated concrete slab. Again, this is the most popular type of shear connector, which we call headed stud shear connectors. But of course, as I discussed, they are patented items and you have to buy them from specific companies, quite costly. So people try other type of shear connectors also. They are allowed now in IS 11384. So we can make our own different type of shear connectors using angles and reinforcement bars. And of course, different type of composite columns are there. These are some of the photographs of composite construction. So we can say like Millennium Tower, Austria, then Citibank, Duisburg, then parking deck, DZ. So different mega structures using composite construction across the world. You can see here the studs are placed on the columns also. So if you use column, then we weld studs at the column also to have a composite action between steel and concrete. And these are composite columns forming the mega columns. So one mega column consisting of many composite columns. This is like you can see here, corner steel post is embedded in the core wall, and you can see a lot of shear studs here. These are actual photographs. Now, as Jensa was talking about fire resistance, so now there are fire resisting treatments also. So we can encase the structural steel elements within the concrete also. So different type of composite actions are possible. We can cover the elements with fire resisting board. We can cover the elements with fire resisting plaster. This is like concrete encasement of a steel frame. So we can have inside steel frame, and then we can have a concrete encasement. This is a typical composite construction. If you see, there's a steel beam, concrete slab is placed over here, and studs are here. Now, we'll discuss about some challenges. One is there are damages in existing concrete slab. They may be due to higher tensile stresses, aggressive environment, excessive loading. So in this case, we can strengthen them by using continuous connection. Time-dependent effects can be controlled, or smaller time is required. So people worked about 2 to 3 decades back on alternative type of shear connection. And now again, people are looking for that. And that is sort of, if you see what happens is if you use conventional shear connections, one of the challenges is there are cracks near the shear connections. You can see these actual photographs. So there is all cracked line all along the shear connections. So now thought process is going in academia that can we find out some connectors which are continuous so that these shear pockets, they don't get developed. So now again, people are working on this adhesive shear connections. So you can have a continuous adhesive layer so that all the shear stresses, they're distributed uniformly. Yes, there are challenges with this, and one of the biggest challenges, again, the fire resistance, because epoxies also have limited fire resistance. But we can control the time-dependent effects. That was a brief about this composite construction. Now I'll come to second presentation. Having seen that, a natural question arises, and like Jensa was also showing the photographs and of the uses of the steel construction or composite construction worldwide, then what is that which is limiting the use of this composite construction around in our country? That's a big thing to look into. That why we are so hesitant to use the composite construction, because this is a very basic principle that if we use steel in tension, concrete in compression, we use them together, it's going to give us a good effect, it's going to be a faster construction, it's going to be a better construction, economical construction. And there is no rocket science in this. Then what is preventing us from this? So based on my experience in I did my PhD in fact in composite construction 25 years back. So I have seen that there are a lot of solutions present in academics, or people are using those solutions there, but there are some challenges still. And even we have a course here, only few IITs have a course on this design of steel concrete composite construction. We have a core course here, in fact, for masters. So there also we face some challenges. That's why I roped in our PG students. I think they're here, Shubham, Pranjal, and Kavya. Last time we had this course, so I asked them to jot down what are the challenges which they see here in going through this subject. Now, as of now, the code which is available is 11384/2022. It was revised in 22, and many of us still are not much aware of this code, because even if I talk with my friends in academia, they're also not aware that this code was revised in 22. So this defines now composite construction, as composite construction consists of the use of prefabricated steel structural units like steel beams and steel open web joists in combination with concrete elements and often with steel reinforcement. This is quote unquote taken from IS 11384. And it also says the design and construction should ensure monolithic action between the structural steel and concrete components so that they act as a single structural unit. This is how IS 11384 defines it. As of now, today, if you have to design a composite construction, then we need to use IS 800 also, because this IS 11384 relies heavily on IS 800 while defining the classes of steel sections. And along with that, we also need IS 456, because we know that for concrete, we have to look back to, these are mother codes you can see. For steel, mother code is IS 800, we know. And for concrete, mother code is 456. So when we are dealing with IS 11384, we have to take into account both the codes also. Now, going a little back, this IS 11384, it was first published in 1985. And it was hardly 5 to 10 page code when I was doing my PhD. So I think hardly the clauses were only in 3 to 4 pages, when Eurocode was of 200 pages, the same composite construction. So this is how we were lagging behind in this composite construction. Of course, now we have code. So earlier code was published in 85, and then it was revised majorly in 22. And these are the major modifications actually which were made in this latest code. One is now there are explicit provisions for the design of slab, beam, and column of composite construction. And that's a very good initiative. In fact, earlier there was no explicit mention of design of this. Like we know that in IS 456, IS 800, we have separate clauses for design of beams, columns, slab, etc. Similarly, now in IS 11384, they have put that. Two types of composite column constructions have been covered: the concrete encased steel columns, both fully encased and partially encased, and concrete filled steel columns. So two types of columns are considered. Yes, still there's a little bit of gap, because there are still some column sections, some column types which are not covered in both of them. Then we have to take our own conscious decision which clause we have to apply. Then the following types of composite slabs are presented: profiled sheeting, serving as formwork for the reinforced concrete slab, which we have discussed in last presentation. The embossed profile sheeting, acting as formwork and also as tension reinforcement, acting along with in situ concrete. And there are improved provisions for the design of shear connectors and their testing method. So this was missing earlier in the earlier version of the code. Revised limit state of serviceability is also now included to check for deflection, vibration, and fire performance of steel concrete composite components. And there are additional specifications on use of light gauge steel and lightweight concrete in this revision. I think that will also be covered in one of the lectures. Now, these are the reference standards which have been used, and in fact, that has been already written in 11384 forward, that they have used many clauses from this also. One is Eurocode and another is American Institute of Steel Construction. So these codes have been used heavily as reference standard. Coming to composite slab, we have already discussed. They consist of metal decks spanning between the supports and acting integrally with the concrete after concrete hardens. You know, it supports loads during construction. It develops adequate composite action. It transfers in plane loading. It reduces the volume of concrete in the tension zone of the slab, and it distributes shrinkage strains and thus preventing serious cracking of concrete. So now this is how there's Annexure C now in IS 11384, and it gives sort of steps of the design of composite slab. So as per this annexure, we have to first classify the sections. Steel section as per IS 800. Then we have to compute effective width of concrete slab as per clause 8.3.3 of this code. Then we have to calculate design load, moment, and shear. Then we have to calculate the design moment capacity as per table 22. And then we have to check for bending. So these steps are now given. So it makes it quite handy to design composite slab. So this is how we design composite slab as per IS 11384. Idea is just to instill confidence. Yes, now we have those codal provisions, we have those standards which can help us in designing this. So there's a section classification given in IS 800. The steel section in composite slab can be classified as class 1, 2 and class 3. And plastic stress distribution over the cross section should be used for section classification 1 and 2. We know we do that in steel also. And in classification 3, the elastic stress distribution should be used because we know it's not going in the plastic range. Taking into account the sequence of construction and effect of creep and shrinkage, again they are defined in a clause. So this table 2 has been picked from IS 800. So there in 11384, it directly links to IS 800 table 2 that you first classify your section from IS 800. This is very important, effective width of the composite slab, because we cannot take the entire slab to be effective for the composite action. So now there are well-defined provisions for the effective width of the composite slab. So these figures have been picked from IS 11384. One is, you can see, transverse section. One is longitudinal section. So for mid-span and internal support, we have different formula for effective width. As for end support, we have different formula for effective width. So we can calculate the effective width. Only that effective width, that concrete has to be taken into account in calculating the properties of the composite section or the second moment of area and area of the composite section. So once we calculate these effective widths, now we have section available with us. Once the section properties are available with us, we can calculate the design moment capacity. So again, different your XU, that is the neutral axis, can lie at different levels. So depending on the location of your XU or the neutral axis up to which concrete is active, different formulas have been given and different stress distributions have been given. Again, this is readily given in IS code. So for XU less than the depth of slab, there is one clause, and if XU is between DS and DSP, there's another clause, and XU greater than DS, there is another clause. So depending on your location of XU, and of course it will go by trial and error. Initially you assume one value of XU, and if you see you are getting back the same value of XU after the analysis, it's fine. Else you have to go for another assumption. So there can be 3 assumptions. You have to go one by one with these assumptions. And once you have that, then you can calculate the design moment capacity. Again, now the formulas are given in Annexure C of IS 11384. So depending on, once the location of XU is defined, then you can calculate the value of XU based on that, in which region it is there. And based on that, you can calculate the design moment capacity of the composite slabs. And of course, here we assume full shear connections. There are a lot of variables here, but fortunately all the variables are well defined in IS code. So they're very simple variables. You can always calculate these variables. Redistribution of moments, that's very important, because here we know whenever there is concrete, there's always going to be some redistribution because of the cracking of concrete. So it is reallocation of bending moments in indeterminate structure. We know in determinate structure, there is no redistribution, but in indeterminate structure, there's going to be some redistribution. So it can be when there is yielding of highly stressed section and to maintain overall equilibrium. So again, there's a table given here for calculating for assuming the moment redistribution, table number 5. So you can calculate the limits to percentage redistribution. So from here, you can pick the redistribution. It is permitted if adequate rotation capacity is available, and shear connectors ensure full or partial interaction. Local buckling of steel is prevented, and the steel member should put a zero slip here, but actually the head is slipping out. It itself is bending. So that also needs to be taken care, that how much we can, this is the gap which is induced by the slip, how much gap we can allow which is induced by the slip. So there is a complete provision given in IS code, and typically is like the diameter of the stud connector welded to flange should not exceed 2.5 times the flange plate thickness. Height of stud connector shall not be less than 4 times diameter nor 100 mm. Typically, they come in the size like 18 mm stud, 20 mm stud, 25 mm stud, 22 mm stud, something like that. The diameter of the head of stud shall not be less than 1.5 times the diameter of the stud, and the depth shall not be less than 0.4 d. And size of the fillet weld joining other type of connectors to the flange plate should not exceed half the thickness of flange plate. So these are some of the provisions which we need to follow if we are actually want to actually use 100% of the capacity of the shear stud. And then, of course, we need to calculate because ultimately it is carrying the shear. So there will be some amount of shear and there will be some number of shear connectors. And those total number of shear connectors, they should be able to resist that total shear. That's a simple mathematics. So then the question comes back, then what is the capacity of one shear connector? So for that also, now the provision is given in 11384. So here you can calculate the shear capacity of one connector, and based on that you can calculate the number of shear connectors. And you can see here it's a simple equation. It is based on one is this FUS, which is the ultimate tensile strength of the material, pi d square by 4. This is the area of the stud, and then there's a factor gamma mv which is placed here, and then there's another clause which is because it is not just interestingly. You can see here that the capacity of shear connector just does not depend only on the steel properties or shear property, the properties of the stud material. It also depends on the properties of the concrete which is covering this. It may be strong enough, but the concrete which is covering this, if the concrete is weak, then it will not be able to produce the results. So it depends not only on the properties of the steel or its own material, but its strength depends on the properties of the concrete also. You can see FCKEC, because that is also important. So it's not because it's not working in isolation. We'll put a stud aspas, if you have not put anything, any restraints, it will not help. Then another important point, having calculated that, okay, we'll need this number of shear connectors, but then we know that there has to be a limit on the minimum spacing of the shear connectors. There has to be limit on that because there will be influence zones, and then there has to be limit on maximum spacing of shear connectors. So again, those minimum and maximum spacings of the shear connectors, they can be easily calculated by the provisions which have now incorporated in IS 11384. And these are like different formulas which are given in IS 11384. I will not go in much detail, but the idea is, yes, there are formulas available in IS 11384 where you require simple parameters and you can calculate the spacings. And here where the slab is in contact over the full length and where it is not in contact over full length. And of course, then the maximum spacing limit is always given. We know in IS 456 also there's maximum spacing of reinforcement. Similarly, there's a maximum spacing of shear connectors. So it is 600 mm or 8 times the total slab thickness or 4 times the height of the connector, whichever is less. And the minimum spacing also, in any case, it should not be less than 75 mm. So a range has been fixed, minimum, maximum, and of course with these formulas you have to calculate the spacings. We need to know the ultimate static design strength of shear connector depending on the diameter. So directly for the given diameters, directly the ultimate static strength is given. So you can see here the characteristic yield strength is 385 MPa, whereas the conventionally steel which we use is not more than 300. So here we have 385 MPa with minimum elongation of 18% and characteristic tensile strength is 495 MPa. So it's a very high strength steel. Diameter is given, height is given, and you can see the ultimate static strength. So whatever formulas were given, they have put in table also now. So depending on the concrete strength, you can see the ultimate strength is increasing. Same stud, you can see if it is strength is 25 for 25 Newton per mm square concrete. For 50 Newton per mm square concrete becomes 50, from 62 to 105. So the same stud, it is giving different results, different ultimate strength because of the concrete with which it is working. And like you can see here, not only stud connectors, channels are also allowed now by IS 11384. So you can use channels also. And these different sizes of channels are also given. And for them also readily the ultimate static strength is given. One of the confusions which always is there is that if the shear connectors are there, it has to be full shear connection. No, that is not the case. We can go with partial shear connection. We should not always try for that full shear connection. So the partial shear connection is also allowed in IS 11384, and of course the degree of shear connection is simple, whatever is the number of shear connectors required for full shear connection and whatever is the number of connectors which we are providing. So that ratio gives us the degree of fixity or degree of shear connection. So we can have partial shear connection also. Formula is also simple for the partial shear connection. Now, but there are some limitations on the use of partial shear connection in beams for buildings, like headed studs with an overall length after welding not less than 4 times its diameter and shank diameter not less than 16 mm. Neither greater than 25 mm may be considered as ductile. So different clauses are given which put a limit. You cannot always go for partial shear connection, but if you satisfy some of the conditions, then you can go with the partial shear connection. Coming to like what Ashutosh was asking, profile sheet. So there's an exercise again given here, an exercise. But here the thing is, it says a deck sheet is a metal profile sheet used in construction. It's a ribbed sheet made of aluminum or steel. It has referred some IS code. Thickness range is given, profile height is given, pitch is given. So these ranges are given, and it is said that composite slab spans are generally established between 2.5 meter to 3.5 meter, and supporting beams are designed to span distances ranging from 6 meter to 12 meter. So these ranges are given. The only challenge is that what is the size or what are the type of sheets available in the market? That is still missing. Like in steel table, we have sections ISMB, ISHB, and all those sections. This is still missing. But yes, a lot of codes have been referred here. Then the clauses have been given for design resistant of studs with profiled steel sheeting. So once we know the properties of the steel sheet which we are using, then the life is simple. The only challenge here is what type of steel sheet we are using and the properties of that steel sheet. But once those properties are available with us, then we can easily calculate the design resistance of studs. Now here interestingly, the capacity of stud will also change. So the stud, if you are using in simple concrete slabs, its capacity is different. If you are using studs with profiled steel sheeting, its capacity will change. So it's again, I'm repeating, it's not just its own property, intrinsic property. It depends not only on the surrounding concrete, it also depends on the type of the concrete slab or sheet. If you are using sheet, its properties will change and its capacity will change. So here again, formulas are given, and we know that the sheets can be placed in two ways. One is ribs are parallel to the longitudinal section. One is ribs are transverse to the longitudinal section. In both cases also, the capacity of the stud will change depending on the placement of the ribs. There can be a ponding of profile decking as we were discussing, because when we are using it as a formwork and we are just putting concrete over there, then it's not a composite section, it's just a profile sheet which is taking care of entire weight of the concrete. So there can be a ponding deformation. So this we need to take care of, particularly in the long spans. Next is coming to the design of beams. Again, here steps are given. Again, we have to classify our section as per IS 800. We have to find out the effective width. We have to calculate same design loads, moments, and shear, design moment capacity as per different clauses, design shear capacity, and we have to check for shear buckling and deflection. This is the type of composite beam which IS 11384 talks about. So here we can calculate the sagging moment of resistance with full shear interaction, and different rectangular stress blocks are given. So again, position of neutral axis, first we have to define whether it is within the slab or the plastic neutral axis in steel flange or it is in the web, because there can be only three conditions. Either it is in slab or it is in steel flange or steel web. So depending on location of the neutral axis, we can calculate the design moment capacity. And these are different notations given when we do those calculations. So these are the stress distributions. All these stress distributions now they are given in IS 11384. Like if the plastic neutral axis is within the flange of a steel beam, then this is the plastic stress distribution. If it is in with plastic neutral axis in the web of the steel beam, then this is the stress distribution. So different stress distributions, they have now been defined in IS 11384, and we can easily calculate CT and neutral axis, lever arm, and we can calculate the moment of resistance. For design shear capacity also, formulas have been given, and you can see here AV, FIW, root 3, and FIW is yield strength of web, and all these calculations, they can be easily done if we know the properties, section dimensions of the beams. Composite columns, so now here it becomes a little bit tricky because for steel beams or for this composite beams, composite slab, there is only one type of composite beam, one type of composite slab, or at the most two type of composite slab without profile deck, with profile deck. But when we talk about composite columns, there can be a number of combinations. So IS 11384 has tried to cover up most of the combinations. It has divided the type of composite columns in two parts. One is like figure 18, you are seeing fully and partially encased concrete columns. So these type of columns are treated in one way, and then concrete infilled columns, these are treated in other way. So this is how they have defined. But of course, you have some other type of composite action in mind. Then it comes back to our own judgment only that in which category we are going to put these columns. Again, we have to calculate first area, second moment of area. Then we have to calculate the critical buckling load. We have to calculate the design, ultimate design compressive resistance. We have to calculate the slenderness ratio, design compressive resistance, and design bending resistance. So these are the steps. For each step, there's a separate clause given in this. So first, there are certain caveats put here that the composite member should conform to the following condition. The non-dimensional slenderness lambda should not be greater than 2. And for fully encased steel sections, maximum thickness of concrete cover that may be used is limited to CZ and CY, 0.4B, 0.3H. This is how CZ and CY have been defined here. We can calculate CZ and CY. For that, formula is also given. But in diagram, this is how they have defined the location of CZ, CY. And longitudinal steel reinforcement shall not exceed 6% of the concrete area. And ratio of cross-section depth HC to BC is also defined. So it is applicable only within a range of 0.2 to 5. So we can have that ratio 0.2 to 5 only. That is, one dimension can be only 5 times the other dimension. Only that part it covers. This cylinder, non-dimensional slenderness, here it covers lambda. Normally we know slenderness ratio, but here it is non-dimensional slenderness, lambda parameter. So under root Pn by PCR. PCR is the buckling, elastic buckling load, and Pn is the design compressive resistance. So it should be less than 2. That is the clause which has been put here. Then effective elastic flexural stiffness. So here it's a standard thing. We know there will be a contribution by steel, there will be a contribution by concrete, and there will be a contribution by the other reinforcement which we'll put. One is structural steel which we'll put, one is concrete, and one is reinforcement. So all three will contribute. So ES, IS is directly taken. For this IC, it is 0.6 ECM, that's important. So it has already multiplied by 0.6 times the secant modulus. And EST, IST, structural steel, it is directly taken. For long-term loading also, depending on the eccentricity, different provisions are given. So if E is greater than 2D, there's another provision. If it is less than 2D, there's another provision. And then when lambda exceeds the limits prescribed and E by D is less than 2, then it's saying that the effect of creep and shrinkage should be considered. So if you have to consider the effect of creep and shrinkage, we know that to consider the effect of creep, all of us know that we have to reduce the modulus of elasticity of concrete. So that reduction in modulus of elasticity of concrete in IS 456, we know it is given by as EC upon 1 plus phi, where phi is creep coefficient. Here it is given in another way. So you can reduce the modulus of elasticity of concrete, and some adjustments you can do. And this lambda value is also adjusted accordingly, limiting values of lambda for long-term loading. And then there are some imperfection curves also. So we can take account the imperfections also in composite columns. And then this is the table again given for design compressive resistance. Depending on, you can see the type of the column. If it is partially or fully encased composite section, formula is different. If it is concrete filled rectangular tubular section, formula is different. If it is concrete filled circular tubular section, the formula is different. So there are different formula for different type of composite columns. And then design bending resistance of composite column is also given. So again, simple, you can see there will be a sort of a contribution by structural steel. One is contribution by structural steel, one is contribution by reinforcement, one is contribution by concrete, and of course there will be some factor of safety. And then these are standard interaction curves. They also need to be fulfilled. So these clauses are also given here. Now coming to like having done all this, there is still some missing gaps when we try to use IS 11384. And of course, whenever we have used IS 11384, INSDAG has come up with a very good publication where they have given ready-made examples, solved examples for this composite beam, composite column, and composite slab. For composite columns, they have considered 3 to 4 type of composite columns. We have also used those publications, but still there are some missing links and some mistakes which are left out in IS 11384, which creates a lot of confusion. One is in effective width formula. The effective width at an end beam, actually it should be at end support. So that has been wrongly written. And this B1 is equal to 0 for end span. It has no meaning there. So that needs to be corrected. Maybe whenever the new revision will come, but else it creates a lot of confusion when we are calculating the effective width as per IS 11384. And this is how we try to find out, because we face a lot of challenges and our students also face a lot of challenges when we're solving the problems. Then of course we went to those standard codes, American Institute and Euro codes, and we tried to correlate the things, and lately we found that it is actually support and this is mistakenly written. As to the best of our understanding, it needs to be corrected. Similarly, another problem is one side they have written the height of stud connector shall not be less than 4 times the diameter, nor 100 mm. But at the same time in table 19, they have given nominal height as 75 mm. So here also there is a mismatch. So either the 75 needs to be corrected or that clause of 100 mm needs to be removed. Creep effect has been neglected at ultimate state. So it's said that the effect of creep, shrinkage, and temperature are normally neglected in analysis for ultimate limit states. So at times it may lead to some problems. Then for shear connector, idealized slip behavior is considered, but if we consider Euro codes and other codes, they consider the actual load slip behavior. Maybe one of the reasons is they have those ready-made load slip codes of studs, shear studs available with them. In our context, it may not be that simple to find out the actual stress strain curve of this shear studs. So that might be one of the reasons they have insisted upon going for idealized behavior. Then again here this one mistake which they have left out, lambda xu, actually it should be lambda ds whenever we are going to analyze this. So that also creates a lot of confusion at times. So after multiple iterations we came to know, yes, this is a mistake which needs to be corrected. And of course there is excessive dependence on IS 456 and 800. Of course it has to be, because they are mother codes, but again and again it says go back, go back, go back. It creates a lot of confusion. You are having one code in hand, then you have to open 800, other side you have to open 456. At least they can put like for those plastic section, compact section, semi-compact section, they may be replicated there so that you don't have to go back and forth from one code to other code. Plastic hinge assumption also, like here plastic analysis assumes adequate ductility of composite section. In reality, concrete crushing may limit hinge formation. So here Eurocode, it has some separate clause for rotation capacity. We do not have as of now. Maybe because we are evolving in this region. So after some time, we will have such clauses here. Then there's assumption of full interaction is strength calculation of shear connection. Though it allows partial shear connection, but it does not explicitly specify reduction of flexural resistance due to slippage. That how much flexural resistance? Yes, because that's a complicated analysis, but at least for determinate structures, it can allow like what is the reduction of flexural resistance, because the flexural resistance is going to change. It will not be the same second moment of area. For indeterminate structures, it will be iterative process, so might be quite difficult, but at least for determinate structure, they may give a hint how much flexural capacity will get reduced. Like Eurocode, it introduces degree of shear connection to attribute partial connection in shear connector, and it adjusts the flexural capacity. And then the calculation of modulus velocity of concrete. So it is written 0.75 ECM 1 minus 0.5 PDD upon P. PDD is part of factored load permanently acting on column. No, but that range has not been given and nothing has been specified. So again, it comes back to our own judgment, which may become at times difficult. Then there's a limited classification of composite column, as we already discussed, though 5, 7, 8 different shapes have been given, but there may be many more shapes, and in which category those shapes and those combinations shall be placed, that is still left to the user. And then this, like we were discussing about this, there's absence of standardized documents or tables, like we have handbook for structure engineers or this steel table, but here that thing is missing, like for sheets, so we get stuck up there. Of course, INSDAG has one publication, one is this publication, Steel Concrete Composite Construction, Design Process of Structural Elements. So here they have given some examples, but along with that, when it comes to these profile sheets, they refer to another publication. We procured that publication also, but there's only one sheet and some details are given. So still a lot of things need to be done there, because there's so many properties you cannot calculate by yourself. It has embossing, it has profiles. We cannot have those formulas with us. We don't have those. We can calculate second moment of area, Z, etc. IS code asks that. We do not have that, and we cannot calculate that for each sheet. So maybe some table can be put there. This is like how students went there. They visited one plant here. So most of these things are like whatever challenges we faced in our last class. So I think if they are there, Shubham, Pranjal, and Kavya, are you there? Yes. Shubham? Where are the other two? So I think they have prepared most of the presentations. So we should. These are all. But last semester we were together in a class, so whatever they faced. Thank you, everyone.
Raise these anomalies or the shortcomings to DIS. IS 138. Yeah, because they will take long time to
They will take
issue
long.
the other
Yes,
version. But they
the
can certainly issue an errata.
errata.
It's always there. So when you do changes in our code, that's okay. It should come in the
Code.
appendix kind of thing. There's another thing. We have talked a lot about the composite column, enclosed columns, or concrete filled tubes, that kind of thing. But there is nothing about the composite beam. Whatever composite beams are mentioned, they are with the composite slab over that deck. But
Yes.
there is no encased beam.
That is not there.
Here, worldwide.
Worldwide.
If you
Yes,
remember
yes.
that discussions we had with your team also.
Mm-hmm.
In one of the projects, we were requiring that.
That is missing.
Literature where a concrete beam with an embedded steel section
Yes, yes.
can be analyzed. Because in many of the high-rise buildings where the shear walls are coupled, the coupling beam has huge shear. And for that, even sometimes the rings cannot be provided. Even the diagonal bars are not adequate. So embedded steel plates are the solution which worldwide people are using. But I don't know what principles they are adopting.
Okay.
There is no thing. That can be developed under some kind of study or research.
That can be done.
Even in some of the cases, concrete beams, we have tried to externally fix the steel plates.
Yes.
For retrofitting
Mm-hmm. That is also not there.
don't have that analysis.
Don't have that.
It's all thumb rule kind of thing we are doing.
In fact, some places people are using externally pre-stressed composite sections. So that is also missing here.
Thank you, sir.
Thank you. Thank you.
वो तो मैंने दे दी थी आपको
Thank you, sir. And I request Mr. Munib, sir, to please present the memento to Professor Chaudhary, sir. Now, for the next session, I would like to request Mr. Munib Mehraj, sir. He is an assistant manager at INSDAG, working at the intersection of LCA, green building evaluation, and steel and infrastructure consulting for steel-based construction in India. He works closely with INSDAG's founding members on market sizing studies, sectoral insights, academia industry collaboration, and co leads INSDAG's B2B and academia engagement across northern and central India. He is an active member of the BIS MSD 12 Committee on Resource Management and is a certified professional with IGBC and GRIHA. A civil engineering graduate from Thapar University, Patiala, he previously worked with Shapurji Palonji Group, Mumbai, and regularly contributes to leading infrastructure and construction magazines on sustainability, green buildings, and low carbon infrastructure. I welcome you for the next session, sir.
So which one? Analysis. I'll just copy that. अच्छा.
Good afternoon. I was here some time back. But it's indeed a pleasure to be in the same group of names as Mr. Jay and Mr. Sandeep Chaudhary, Ashutosh sir. So it's really unreal for me, and I'll just try to do whatever I can to do justice to this. So I'll be very quick. Actually, we're out of time. So whatever I'm going to discuss, it's all practical. These are real life case studies that we have done. And let's make it a interactive session. So I'm speaking, I want you to speak as well. So how many of you have you heard of sustainability? Just a show of hands. Be honest, there's more than that. Yeah. How many of you have heard about LCA? This one. There's a difference between LCC, life cycle costing, that DG sir was telling, and LCA. How many? Okay. And how many of you know, just like we know, when you're designing some structure or when you are buying, for example, I'll go to BM Indore, I'll tell him, give me 100 tons of steel. So I know I need steel in tons. So how many of you know how do we quantify sustainability? So there should be a unit. Is there a unit, anyone?
Yes.
Carbon. Yeah. And how many of you have seen any calculation? Just like we see design, we have seen design calculations, bending moments and stuff. But have you seen any calculations where we actually get the carbon? Any of you?
No.
Carbon footprint. Yeah. But not in this regard. Yeah. So I'll show you 3 examples and I'll take you through how we do it, and we'll try to memorize it in our memory through some real life examples so that it is etched in your memory. And this topic is actually for all of us. Most of the civil engineers don't know it. Most of the professionals don't know it.
It's the new normal.
New normal. Yes, sir. So I'll take you through sustainability landscape, no theory. I'll take you through the parameters. I'll try to make you understand through an example. Then we'll talk about EPDs. I'll take you through a digital tool, just like we have designing, we have STAD. In digital, in this LCA, we have a tool. I'll take you through that as well. And then I'll show you 2 examples that we did for our founding members only. One was for SAIL and one was for Tata Steel. I'll show you these examples too. And what are the takeaways? It will be a short, crisp presentation. So about me, not bragging, but before my engineering, even when I was working, I did not know about sustainability. I'm actually a certified professional. That's why I'm standing in front of you. But at the same time, I love to know from you as well. I know very little. I'd love to have your thoughts as well. So just go back. How much steel is recycled in the world? Any number? So in the world, it is 85%. And how much steel is recycled in India? About, around 22%. That's around 30. Yeah.
What happens to
Full fresh.
which is
It
not
either
getting recycled, उसका क्या होगा?
landfill, reuse. It's not recycled. Only I think now Tata Steel is coming up with a factory in Ludhiana where they are actually going to use scrap steel. But other than that, this is at 85. This is at 22%. So why do you need to know carbon? Why do you need to know carbon? Why do you need to know this emissions? Because maybe in the next 10 years, just like we are talking about grade of steel, 310 चाहिए, 350 चाहिए, 250 चाहिए, कल को आपको ये भी शायद जानना पड़े कि इसका कार्बन फैक्टर कितना है. There will be a time in the next 10 years, you'll have to know, अच्छा, grade of steel इतना है और इसका carbon इतना है. So we'll try to see that. This is for all of you techies in the last 5 years. You can see there's a jump in the people who are searching for sustainability. So it is for construction only. You see sustainability in construction, there's a jump in people who are actually searching for this topic. And just to give you an overview, sustainability is now entering industry like anything. There are brands currently in the industry who are marketing their products by saying it's premium. For example, if you go to buy something, you go to Aldo, you go to Louis Philippe, they are charging you for the brand. But now in steel and in other materials, they are charging you by saying our material is sustainable or green. This is one such example. This company's whole brochure is, can you imagine, this is a brochure for a steel company. So this is what is happening. So what is life cycle assessment? So it might sound very difficult, LCA and stuff, but it's actually very practical. So in school, when we were in school, everyone said, Indore is the cleanest city, by the way. So you would note the recycled more than any other city in the country. So what is LCA is basically, you go, when your raw material is extracted. For example, you have that Limca का वो कांच वाला bottle आता है. It's manufactured somewhere. It comes to you via some trucks. You buy it, you consume it, and you then put it there. And then it again goes to recycle or rewash. So this whole cycle, we call it LCA. And life cycle costing was different. So LCA, so there's a difference, A and C. LCA is for emissions, that is carbon. LCC is for costing. The circle is same. So this will remain the same. But for this cycle, I'll calculate the carbon, and someone who is doing an LCC, they'll calculate the cost. Now again, these are terms that the sustainable professionals use so that we don't understand. But these are actually very simple. This is cradle to cradle LCA. What do you mean by cradle? When a baby is born, you put them in a cradle. So cradle to cradle means that the baby comes back to the same place. So how is it possible? Through recycling. So if I move from production, this is the whole cycle. If I move from production to use, we call it cradle to site. If I move from production to recycling and I don't complete the circle, it is called cradle to grave. That means the steel is there in the landfill, or steel or some other material. But when I complete the whole circle, this is cradle to cradle. So very simple, self-explanatory. Now, you can understand LCA if you understand this slide. Just don't remember it. So in the next few slides, we'll come through these three. That is, we'll come through A to D, then you will get to know what is EPD and what is LCA. So these are all interconnected. Just for the first case, many of your students, you would be applying to some US universities, or even if you are professionals, you will be applying for some award or something. You need to apply, right? So consider your A to D, consider your syllabus. That this is my syllabus, I need to do it. EPD is your marks, and LCA is your application that you actually fill. उसमें आपके marks भी आ जाते हैं और उसमें syllabus में ही आपको रहना पड़ता है. Now A to D में जो बोल रहा था ना, these are actually 1, 2, 3, 4, 5 ऐसे करके ये जो पहला वाला हम जो देख रहे थे अभी, इसको डिवाइड किया हुआ है. मतलब इसको बोला है A, इसको B, इसको C, इसको D, जस्ट नाम देने के लिए. So when I talk about A1 to A3, सिंपल टर्म्स में आपका जब स्टील माइन हुआ, माइन से मैन्युफैक्चरिंग तक मेरा फिनिश स्टील, माइन से मैन्युफैक्चरिंग तक आपका फिनिश स्टील. तो इसको अगर आप याद रखोगे, आई हैव जस्ट पुट सम हाइलाइट्स. A1 to A3 को आप कार्बन हॉट जोन बोल दो, बिकॉज दिस इज वेयर मोस्ट ऑफ द इमिशंस ऑफ एनी मटेरियल कम व्हेन इट्स मैन्युफैक्चर्ड. सेकेंड इज A4 to A5. Whenever you make any material, आप कुछ भी बनाओगे, you have to transport it. तो उसके जो emissions हैं वो A4 to A5. We call it distance quantified. Then this is one example. We were seeing transport. Now जब आप transport किसी material को करोगे, there would be it will use diesel, it will use petrol in India mostly. So there will be emissions. तो वो वाले emissions भी material में आ जाते हैं. जस्ट लाइक आपका कॉस्ट, मैं अगर टन लेने जाऊंगा सर, उसमें तो आपका फ्रेट कॉस्ट भी लगता है, तो ये वाला भी ऐड हो जाता है. दिस इज ऑल्सो एडेड इन द कार्बन. सो व्हाट कंपनीज लाइक टाटा स्टील यूके एंड टाटा स्टील इंडिया इज ऑल्सो डूइंग नाउ, वो अपने जो ट्रक्स है उनको CNG और दे आर यूजिंग EV ट्रक्स. तो नाउ विल से व्हाई, बिकॉज दे आर, जो उनका रीबार है, जो भी प्रोडक्ट है, उसमें ये वाला इमिशन कम कर रहे हैं. कॉस्टिंग भी कम हो रहा है और इमिशन भी कम हो रहा है. नाउ ए से हमने देखा मैन्युफैक्चरिंग हो गया, ट्रांसपोर्ट हो गया. उसके बाद क्या होगा मटेरियल के साथ? विल यूज इट, सो वी कॉल इट इन सर्विस. अब ये वाला जो होता है यहाँ पे क्वांटिफिकेशन, ये तो मान लीजिए मैं एक लूंगा, अबे सर एक लेंगे, वर्मा सर एक लेंगे. विल यूज इट इन डिफरेंट वेज. सर कुछ मान लीजिए कमर्शियल बिल्डिंग बना लिए, मैं रेजिडेंशियल बिल्डिंग बना लिया, तो एमिशंस अलग अलग होंगे. सो दिस इज वन जहाँ पे मे बी अगर मेरा और अबे सर का मटेरियल भी सेम है, बट हमारे जो एमिशन फैक्टर्स हैं दे कैन बी डिफरेंट, बिकॉज वी आर यूजिंग इट इन डिफरेंट वेज फॉर डिफरेंट टाइम फ्रेम्स. सो वी कॉल, इसमें एक्चुअली दिस इज वेयर इट इज वेरिंग. यहाँ पे मान लीजिए एक लिम्का का और एक कोक का, डाइट कोक का बॉटल है, दोनों का प्राइस, मे बी दे आर कमिंग फ्रॉम द सेम कोका कोला फैक्ट्री, बट दोनों का जो प्राइस है दैट इज डिफरेंट. अब बहुत ज्यादा इंडिया में क्या हो रहा है ना, इसके आगे नहीं जाता है, दिस डजंट गो बियॉन्ड दैट. बट जो सारी गेम है वो मैं आपको नंबर्स के साथ दिखाऊंगा, उसके बाद चेंज होती है. नाउ दिस इज एंड ऑफ लाइफ स्टेज. वी कॉल इट द एंड इज नॉट द एंड. सो इसमें क्या होता है, आपका जो मटेरियल का लाइफ खत्म हो गया, नाउ यू विल डिमोलिश इट. डिमोलिश करके, बहुत केस में इंडिया में नहीं होता, बट दिस इज वन स्टेज, वी कॉल इट C1 to C4. एंड नाउ डी, दिस इज द मोस्ट इंपॉर्टेंट. मैं आपको एलसीए में क्वांटिफाई करके दिखाऊंगा व्हाई इट्स कॉल्ड द मोस्ट इंपॉर्टेंट. यहाँ पे स्टील स्टोरी डजंट एंड एट डिमोलिशन. मतलब जब आप रिसाइकल करते हो ना प्रोडक्ट का, यू आर रीबर्थ हो जाता है उसका. तो क्रेडल टू क्रेडल यहाँ से स्टोरी शुरू हो जाती है. तो इफ आई हैव जस्ट समराइज दिस फॉर यू, जो सबसे ज़्यादा डोमिनेंट है, जहाँ पे सबसे ज़्यादा एमिशंस होंगे, वो होगा आपका A1 to A3. A4 to A5 सेकेंडरी होता है. बी जो है ये मैं कुछ यूज़ करूँगा, आप कुछ यूज़ करोगे, बिल्डिंग में आपका अलग हो जाएगा. सी जो होता है ये मैनेजेबल होता है क्योंकि आप बिल्डिंग को जो है डिमोलिश कर रहे हो. और डी जो है, जस्ट रिमेंबर दिस इज वेरी इंपॉर्टेंट, ऑफसेटिंग पावर. ऑफसेटिंग पावर होता है कि मैं उसको नेगेट कर रहा हूँ. एंड आई विल शो यू विद एग्जांपल्स. तो अभी तक यहाँ तक की ये बात समझ, ये वाला तो समझ आ गया कि ये मैं क्यों बोल रहा था A to D सिलेबस, ये वाला. तो सिलेबस बेसिकली क्यों, क्योंकि आपको एक ओवरव्यू मिल गया एक्चुअली हो क्या रहा है. अभी ये जो मैं A1 A3 ये सब बोल रहा था, देयर विल बी नंबर्स अटैच्ड टू इट, बट यू गॉट द बैकग्राउंड स्टोरी, वेयर इज इट कमिंग फ्रॉम. So this is what we did for one of our projects. This was one INSDAG study. These, whatever I'm going to show, two studies we have done, one with SAIL, one with Tata Steel, but this is an INSDAG study where we had three options. एक हमने एक G+4 बिल्डिंग था, हमने एक कंक्रीट में किया यहाँ पे, और एक स्टील ओपन सेक्शन में किया. स्टील ओपन सेक्शन में आप जो ब्राउशर्स देख रहे हैं सेल के, सो दे आर ओपन सेक्शंस. एंड स्टील ट्यूबुलर सेक्शंस, ट्यूबुलर सेक्शंस हो गए जो आपके पाइप्स आते हैं, जो आपने एयरपोर्ट्स पे अभी देख रहे हो, एयरपोर्ट्स पे बहुत सारा ये पाइप्स यूज हो रहे हैं, ट्यूब्स वी आल्सो कॉल देम. सो हमने जब तीनों में क्वांटिफाई किया, सो दीज वर द GWP numbers. So this is all carbon. How much carbon is quantified? सर इस केस में सर ट्यूबुलर का क्वांटिटी व्हेन वी डिजाइंड इट वाज लेस, और ओपन सेक्शन में वी हैड टू गिव स्टार सेक्शंस, स्टार सेक्शन दिया था उसमें. सो व्हेन यू कैन सी,
Actually, if the quantity would have been added in one
Yes.
of the columns, how many cubic meter of concrete, how many tons of
अच्छा,
open
अच्छा.
section, it would have given more
yes,
meaning to this.
perfect, perfect. तो द रीजन व्हाई आई एम शोइंग यू दिस स्लाइड इज, पहला तो ये है कि सबसे ज़्यादा अगर आप देखोगे तो सबसे ज़्यादा एमिशंस, द मोर दिस नंबर द बैड इट इज. अगर ये ज़्यादा है मतलब आपका GWP ज़्यादा है. तो इफ़ यू कैन सी, जो आपका ओपन सेक्शन है इनिशियल में, व्हेन वी आर टॉकिंग अबाउट A1 to A3, दिस इज व्हेन योर मटेरियल इज मैन्युफैक्चर्ड. तो मैन्युफैक्चरिंग में आपका सबसे ज़्यादा एमिटिंग होता है ओपन सेक्शन, और उससे कम हो रहा है ट्यूबुलर सेक्शन, और सबसे कम कॉन्क्रीट हो रहा है. बट द सारी गेम, ये वाले जो है ना, ये वाले जो ट्रांसपोर्ट हमने देखा, एंड ऑफ लाइफ, ये वालों में थोड़ा ही रोल है. यू सी दीज आर वेरी लिटिल कंपेयर टू दीज. बट सारा जो गेम चेंज हो रहा है वो डी में हो रहा है. नाउ व्हाट इज डी? ऑफसेटिंग पावर. मतलब ये जो वैल्यू है, ये जो भी आएगी ये इससे माइनस हो जाएगी. और ये वैल्यू कैसे आएगी? ये वैल्यू आती है, मतलब मैंने जो मटेरियल लिया था उसका एंड ऑफ लाइफ में क्या हो रहा है, वो रिसाइकल हो रहा है, रीयूज हो रहा है. तो कंक्रीट के केस में ये जो मटेरियल जा रहा है लैंडफिल में जा रहा है. कंक्रीट में यू कांट रीयूज इट. आप एग्रीगेट बना सकते हो बट यू कांट रीयूज इट. तो कंक्रीट में दिस वैल्यू इज 1.87. ओपन सेक्शन में दिस इज गोइंग टू रिसाइकलिंग. तो दैट इज व्हाई दिस वैल्यू इज 6.13, और ट्यूबुलर में दिस वैल्यू इज 4.43. सर नाउ यू आर आस्किंग, अगर क्वांटिटी सर यहाँ पे कम है तो दिस विल हैव एन इफेक्ट एज वेल, क्योंकि सेम क्वांटिटी रिसाइकल हो रही है. एंड देन यू सी, अगर इफ यू शो समवन दिस, वो तो बोलेगा सबसे ज़्यादा इमिटिंग आपका स्टील है, हम क्यों यूज़ करें. बट व्हेन यू शो हिम द होल स्टोरी कि बस आपका तो रिसाइकलिंग भी आ रहा है, तो कंक्रीट लैंडफिल में जा रहा है, बट यहाँ पे तो रिसाइकल में आ रहा है, तो द होल स्टोरी चेंज. यू सी द लोएस्ट इमिटिंग हेयर नाउ इज स्टील ट्यूबुलर सेक्शन. So that is why I said that D has offsetting power. This is one of the takeaways, that पहले तो A to D वो syllabus वाला that thing वो तो आप याद रखो, but ये वाला याद रखो कि जो मटेरियल का कार्बन है वो तो आपके इनपुट मटेरियल पे डिपेंड करता ही है, बट आप उसको कैसे रिसाइकल या रीयूज करोगे उस पर भी बहुत ज़्यादा डिपेंड करता है. नाउ आई विल शो यू अनदर 2 एग्जाम्पल्स. उससे पहले विल गो टू EPDs. सो मैंने क्या बोला था, A to D में A to D सिलेबस जो हमने देखा, EPDs मार्क्स. तो EPD में क्या होना चाहिए? एनी गेसेस? अगर EPD आर मार्क्स तो इट इज काइंड ऑफ ग्रेड कार्ड. तो ईपीडी में क्या होना चाहिए? फॉर एग्जाम्पल वी हैव 2 ईपीडीज अभी करंटली इंडिया में। ईपीडी टाटा स्टील हैज 1 ईपीडी फॉर देयर रीबार्स, जेएसडब्ल्यू हैज 1 फॉर देयर हॉट रोल्ड स्ट्रिप मिल। सो ये जो है, ये मान लीजिए कि आपका ही ग्रेड शीट है, तो इसमें क्या होना चाहिए? क्या नंबर होना चाहिए? एनीवन? You can be right or wrong. It's not, we are not marking anything. तो इस केस में EPDs में एक्चुअली कार्बन होता है। EPDs आर बेसिकली, अब आप बोलोगे कि रीबार इंडिया में तो 10-15 टाइप के रीबार बनते हैं, सब अलग अलग जगह से। रीबार मीन्स TMT सरिया, तो सब अलग अलग जगह से आते हैं। तो सबका जो EPD है, कार्बन है, वो तो सेम नहीं होगा। कुछ किसी और प्रोसेस से बन रहा है, कुछ किसी और प्रोसेस से बन रहा है। तो इसीलिए ईपीडी का एक बेस है। तो व्हाट कंपनीज डू ना, वो ईपीडीज निकाल के दिखाते हैं कि मेरा प्रोडक्ट इज मोर सस्टेनेबल। जैसे मैं वो टाटा स्टील का आपको एग्जांपल दे रहा था, दे हैव वो जो उन्होंने ट्रक्स वाला एक्सपेरिमेंट किया है, सीएनजीज एंड ईवीज, तो वो जब उसमें जो उनका नंबर रिडक्शन होगा, दे विल शो इट इन ईपीडीज। तो ईपीडीज आर काइंड ऑफ डॉक्यूमेंट्स जो भी आपके इवैल्यूएशंस है वो दिखाते हैं। दीज आर काइंड ऑफ योर कार्बन मार्क्स। Easy to understand, they are your carbon marks for a company. EPD टाटा स्टील का होगा, JSW का होगा, सेल का होगा। So these are actually एक कंपनी के किसी प्रोडक्ट का कितना कार्बन है, इमिशन है। नाउ आपका सिलेबस हो गया, आपका मार्क्स भी हो गया, उसके बाद तो आपको एक्चुअली कहीं अप्लाई तो करना है। आपको तो देखना है कि भाई मेरा, अच्छा मैं अगर ये टाटा स्टील का लूंगा, ये सेल का लूंगा, ये जेएसडब्ल्यू का लूंगा, मेरा इफेक्ट क्या रहेगा बिल्डिंग्स पे। वी नीड अ कंपैरिजन। कुछ भी आप करते हो, यू कंपेयर 2-3 प्रोडक्ट्स, फिर आप बोलते हो अच्छा ये वाला सही है। तो सेम वी आर डूइंग हियर, एंड आई विल शो यू 2 एग्जांपल्स where we have done. So the tool that we used, we have this in-house tool which we use. This is One Click LCA. This is a Finland-based company. This is just like your STAD. आपके जो भी सॉफ्टवेयर होते हैं यूज करते हो, in fact जो आपके C++, Python, Visual, consider it like that only. This is an online web-based tool. So we create it just like हम STAD में create करते हैं, इसमें भी हम मॉडल create करते हैं, and then we calculate the carbons. So this was the first study that we did for, this was a conceptual study. This is not an actual building, it's a conceptual building. So this we did for SAIL MLCP, sir, as I was saying. The length is 40 by 25 meters, location is Hyderabad. We first made, my colleague here, we first did the STAD model of it. हमने एक STAD model बनाया. And then from the STAD model, we got these quantities. This is the SAIL NPB. NPB is narrow parallel flange beams. So this is the NPB. तो ये we use these 3 varieties of steel. तो इसमें आप देखोगे हमने 3 सेल के 3 अलग अलग ग्रेड्स यूज किए। ग्रेड ऑफ स्टील 250, 350 एंड 410। तो नेचुरली क्या होता है, नेचुरली दिस इज एक्चुअली प्रीटी स्ट्रेट फॉरवर्ड, बट दिस नीडेड टू बी क्वांटिफाइड। आप देखोगे 250 में जो क्वांटिटी है वो सबसे ज्यादा आ रहा है, बिकॉज द ग्रेड इज कम। आपका 350 में उससे कम आ रहा है, और सबसे कम आपका आ रहा है 410 में, which is very pretty straightforward. This we gave to SAIL, we made a report for them. But then this also needs to be quantified in terms of LC. अगर आप सेम चीज बोलोगे किसी को कि मैंने 250, 350, 410 किया तो कार्बन कम होगा, कोई मानेगा नहीं। सस्टेनेबिलिटी, no one, unless you do it, no one will take it. Then before I go to what were the results for this, pretty straightforward है, वो सबको पता है 410 में सबसे कम आएगा, क्योंकि मटेरियल कम है तो कार्बन की भी कम आएगा। बट जो मैं बोल रहा था कि आपके स्टील के साथ लाइफ में ऑफसेटिंग पावर जो हम बात कर रहे थे, वो सारा आप पे डिपेंड करता है। जो हम डी वाला बात कर रहे थे ना, ऑफसेटिंग पावर, दैट होल थिंग डिपेंड्स ऑन दिस, कि आप एक्चुअली में क्या यूज करते हो।
410 ग्रेड जैसे आपने
हाँ जी
तो प्रोडक्शन प्रोसेस में तो ज्यादा कार्बन खर्च होता होगा
सर, दैट इज द कैच एक्चुअली फॉर आई सेड। हाँ
स्ट्रेंथ का स्टील बनाने के लिए ज्यादा वहां पे उनको
सर, अभी जो आता है एक्चुअली बिलेट्स ज्यादा नहीं है, दे कम फ्रॉम दिस।
आपने हॉट मेटल स्ट्रेंथ पे कुछ ऐड कर दिया जिससे कि उसकी स्ट्रेंथ हो रही है। यू आर नॉट इंक्रीजिंग एनी एडिशनल,
Yes.
You are only changing the composition.
Composition.
उसमें कार्बन का
Yes.
मतलब उसमें मतलब ये ज्यादा नहीं है, एनर्जी इन्वॉल्व ज्यादा
The
है।
temperature required is same, I think.
Same. Yes, yes, that is what I
That is
showed.
what he has shown.
It's actually pretty straightforward,
But
sir.
that ratio is मतलब वो आपका 250 is better than using 410. अगर आप ratio वाइज देखेंगे
सर 250 में तो सर आपका क्वांटिटी ज़्यादा आ रहा है.
compared to that जो आप strength में
This is actually the quantity in tons.
That will not go as
वो proportionate नहीं है ना.
Direct proportionate नहीं.
serviceability will be there.
Minimum section sizes
जा भी नहीं.
proportionate जा नहीं सकता है क्योंकि आपके जो लोकल बकलिंग के जो इश्यूज हैं वो तो उसके अंदर जो है जब आप उसको करते हो
Yes.
ना
There is a minimum thickness of the section.
then it
Yes.
is not proportionate.
Increased. Yes.
That is another aspect. You don't have that discrete inventory, that means the variation is not that smooth. You have to use the available sections which you are making. So you may be, in addition to this tonnage, there should be utilization ratio given. Then you
Okay.
will come to know whether the 299 ton is with 0.85 utilization ratio.
Yes,
and
yes,
with
yes.
0.8
Yes,
ratio.
we'll
Maybe.
have. Yes, so this is a good suggestion. हाँ जी.
What is carbon number against 250?
Sir, carbon, I'll show it after that. तो before I go for the, as sir said, for in India, luckily ये जो सारे आपके grades आते हैं, these come from the same, in fact from the same facility आते हैं. But in UK and when we do it for UK के कुछ products के लिए, तो उनके जो अलग-अलग products हैं वो अलग-अलग जगह से आते हैं. So that is जहाँ पे वो वाला case होगा वहाँ पे input ये 299, 247, this will have a higher impact. Here it is pretty straightforward. But before we go to what were the results for this, आपका जो ये D है, जो offsetting power है, वो सबसे ज़्यादा डिपेंड करता है कि आप स्टील पे क्या करोगे उसके बाद. मतलब आपके पास वो कांच वाला बॉटल का एग्जांपल दे रहा हूँ, देयर विल बी सम विल थ्रो इट इन रिवर, देयर विल बी सम वो उसको तोड़ के कहीं फेंक देंगे, देयर विल बी सम वो जो वहाँ पे ये बास्केट होता है, दे विल पुट इट देयर. सो फॉर ऑल दीज थ्री केसेस द रिजल्ट्स वुड बी ऑफ कोर्स डिफरेंट. So for steel, there are 3 EOL. EOL means end of life. तो एंड ऑफ लाइफ जब स्टील का होता है, एक स्ट्रक्चरल स्टील किसी भी सेक्शन का, तो इधर हम उसके साथ कुछ नहीं करते हैं, ऐसे ही पड़े रखते हैं इसको स्क्रैप की तरह, कुछ वी डोंट डू एनीथिंग, और वी रीयूज इट एज मटेरियल, हम उसको रीयूज करते हैं. बट दिस इज ऑल्सो वेरी स्पेशल केस. मान लीजिए मैंने यहाँ पे कोई सेक्शन लगाया था, वो 40 साल बाद मेरे को कहीं यूज होना चाहिए, सो दैट आई कैन रीयूज दैट. एंड द ईजिएस्ट वे, बट इंडिया में जो बहुत कम हो रहा है, दैट इज स्टील रिसाइकलिंग. आप रिसाइकल करके स्क्रैप करके एक नया प्रोडक्ट बना लो. सो बेस्ड ऑन दिस मेरा जो सॉफ्टवेयर है, मैं तीनों में से कोई भी डाल सकता हूँ और तीनों में वैल्यूज अलग है. फॉर कॉन्क्रीट डू नथिंग तो सेम ही रहेगा, या आप कॉन्क्रीट को क्या यूज कर सकते हो, आप उसको एग्रीगेट यूज कर सकते हो, उसके कुछ निकाल के ऐसे यू कैन जस्ट पुट इट समवेयर ऐसे जस्ट फॉर द फ्लोर्स, और उसको लैंडफिल में जाता है. कंक्रीट में देयर इज नो वे यू कैन रिसाइकल और रीयूज, इट विल गो टू लैंडफिल.
Some research is going on to
Yes.
use it more effectively.
More effective. Yes. Then what were the results? Results, as I said, are pretty straightforward. For 250, the lowest carbon emissions are in 410 because the quantity is less and they are all coming from the same. हमने जब उसको input भी किया था, तो they are all coming from the same factory. So these were the results. In 410, this is the lowest. And so here again, my pointer is not working, but just see A1 to A3 में the value. Although it is मतलब ज़्यादा आपका तब भी 250 में ही है, but see ये how big of a value this is. So in this case हमने माना जो आपका स्टील है, it is going to recycle. We thought कि सेल का आपने आज NPB कोई सेक्शन लिया, after 40-50 years the same material तब तक recycling हो जाएगा and this can go into recycling. So that is why these numbers are huge and they play a high role. ये 1 लाख 3 लाख, it's a very big number. So these values actually play a high role in this. Another application I showed you, अभी आपके पास A to D, तो I think you have now a pretty good picture what A to D is. And उसके बाद आपके EPD जो हमने जो सर बोल रहे हैं 250, 350, 410 एक ही जगह से आता है, तो we get it from EPD. तो EPD में आपका उसका कार्बन नंबर लिखा होता है कि कितना एक्चुअली इमिट वो प्रोडक्ट करता है एज अ मटीरियल. एंड देन LCA इज एप्लीकेशन. अभी मेरे पास ये दोनों चीज़ें हैं, तो आई जस्ट हैव टू पुट इट, मेरे को अपना जो मेरा रिक्वायरमेंट है उसमें पुट करके आई हैव टू गेट द फाइनल रिजल्ट्स. Then this is one live case study that we did. This is Tata Medical Hospital, Bokaro. This was also submitted to Construct Steel, which I showed you earlier. This is an actual building. So this building is actually LGSF. So LGSF is light gauge steel frame. Light gauge steel frame is basically Abhay Gupta sir has done a lot of PMAY lighthouse projects. So these are basically cold form steel sections, specialized sections that come out. So they have used this. Tata Steel has a special brand that goes under Tata Nestin, sir, right? Tata Nestin? Yeah. Tata Nestin does these projects on LGSF. So they made this building in West Bokaro totally in steel. This was totally in steel. So what we did, we just gave them a comparison. We said, आपने तो steel LGSF में बनाया, we'll give you a comparison with RCC. Cost का नहीं, we did nothing for cost, we just quantified for LCA. कि आपका अगर LGSF में जो आपने बनाया, what would be the carbon number, and आपने RCC में, अगर आप RCC में बनाते, तो कितना emission होता. So this is the BOQ for that we received from Tata Steel. इसमें देखिए जो आपका cold form steel है वो hot rolled steel coil से ही आ रहा है, and some plates are being used. And then इसमें in the earlier sale MLCP case we didn't consider the water, but एक जो बहुत इंपॉर्टेंट फैक्टर है, जब आप स्टील का बिल्डिंग बनाते हो तो आपका वाटर इज लाइक वेरी लेस. आपका वाटर रिक्वायरमेंट इज, मतलब वाटर तो स्टील में लगता ही नहीं है, आपको सिर्फ प्रोडक्शन में लगता है, बट दैट इज ऑलरेडी अकाउंटेड फॉर. बट जब आप कॉन्क्रीट का बिल्डिंग बनाते हो आपको मिक्सिंग में भी लगता है, क्योरिंग में भी लगता है. आई एम नो वे सेइंग कि कॉन्क्रीट इज बैड, वी आर इन फैक्ट सिटिंग इन अ कॉन्क्रीट बिल्डिंग, सो इन नो वेज कॉन्क्रीट इज बैड. आई एम जस्ट सेइंग कि दिस इज वन पॉइंट दैट वी शुड ऑल्सो लुक एट. So इसमें जो हमने assumptions लिए EOL के, जो offsetting power I was talking about, इसमें जो concrete है we assumed it goes to landfill, जो आपका rebar है we assumed it goes to recycling, and structural steel we assumed it is reused. Now this is a very special case, we assumed as this is a special building, ऐसा हो सकता है कि we'll reuse this structural steel, and also brickwork we said कि landfill में जाएगा. And then when we came out with numbers, so इसमें भी वही हुआ, कंक्रीट और LGSF मटेरियल वाइज सेम थे, बिकॉज एमिटिंग स्टिल इंडिया में जो स्टील एमिट बन रहा है इट इज अ बिट ऑन द हायर साइड इन टर्म्स ऑफ कार्बन. तो ये वाला आपका जो देखो ऊपर वाले A1 to A3 वैल्यूज आर ऑलमोस्ट सिमिलर, बट इसमें सारा गेम जो चेंज हो रहा है वो डी में चेंज हो रहा है. डी में आपका कॉन्क्रीट में द वैल्यू इज -5.7.
A1 to A3 for concrete should be low,
Sir, in this
as
case,
you have shown in the earlier example.
sir, in the earlier case that was a different building. This one is a different building.
Concrete is concrete.
इसमें सर आई थिंक उसमें the concrete use was different, इसमें तो concrete use was different.
No, you go back to that slide.
Yes.
No, not here. Go to this. Yes. No.
अच्छा अच्छा एक
Regular section, open section.
हाँ जी. I got your point. ये वाला.
Yeah. And your concrete A1 to A3 is almost 40%.
Sir,
55%.
55%.
Of the open section. Tubular is 616. Maybe for LGFS it may be a little lesser.
इसमें कंपेयर, हाँ इसमें कंपेयर सर, इसमें एक्चुअली सर देयर इज अ कैच. इसमें जो हमने प्रोडक्ट लिया कॉन्क्रीट, वी डिडंट टेक इट फॉर एनी ब्रांड. इसमें जो जब आप LCA करते हो तो कॉन्क्रीट जो है एक स्टैंडर्ड, यू कैन यूज इट फ्रॉम ACC, JSW और एनी अदर ब्रांड. तो इसमें एज इट वाज अ यूनिफॉर्म स्टडी तो हमने किसी का नहीं लिया, हमने यूनिफॉर्म कॉन्क्रीट लिया. बट इन दिस केस वी न्यू विच वन इज गोइंग टू यूज. ये वाला जो है दिस एक्चुअली कंसेप्चुअल स्टडी, बट जब आप ये वाला करते हो इसमें वी न्यू विच कॉन्क्रीट वाज यूज्ड. ये जो TMH बोकारो वाला है, सो वी न्यू विच कॉन्क्रीट इज बीइंग यूज्ड. ACC का यूज हुआ है, RMC ब्रांड. सर व्हेन आई टॉक्ड अबाउट EPD, आपका अगर ACC का एक EPD है, आपका JSW या किसी और का और कोई EPD है, दोनों का कार्बन विल बी डिफरेंट. इसमें वी आर कंसिडरिंग, इफ यू सी वी आर कंसिडरिंग, यस बट सर व्हाई इट इज, हमने दोनों में सेम यूज किया है. अगर इसमें ACC है तो इसमें भी ACC है, बट वी आर नॉट कंपेयरिंग इट विद द अर्लियर स्टडी. सो इसमें एज यू कैन सी हमने स्पेसिफाई भी किया है, वी आर यूजिंग सीमेंट फ्रॉम ACC.
You are saying ready mix concrete 767 cubic meter.
Yes sir.
Here also you are saying 767.
67.
This is LGFS.
This is LGSF sir, foundation.
And that is no. But this is with foundation of LGFS.
Yes sir.
But
हमने वो लाइटर होगा.
You have a lighter structure.
Yes,
Your
yes.
light is
Yes. Sir, this
if you not change.
sir, this is what we got actually from the team there. So we have inputted as much.
It should reduce.
It should. आपका LGSF में कम होना चाहिए. LGSF में कम होना चाहिए. Yes. LGSF में कम होना चाहिए. हाँ. हाँ जी सर. Sir, we do it either for 50 or 100 years for both. Sir, we can do it for 150 years as well. In this case, we did for 50 and 100 years. The results you saw earlier were 50 years. इसमें the results are for 100 years.
But then maintenance cost will
वही
again come into picture.
Maintenance cost
Because you would be
एक
coating,
मेरे सर ने बोला था
coatings will be done, na?
रेगुलर
Time to time.
मेंटेनेंस
So that comes in end of life. Regular maintenance.
ड्यूरिंग लाइफ साइकिल
Sir, yes. Sir, during life cycle we can do that. Sir, अगर आप देखेंगे वो 000, we can actually do that, but वो सब में हो जाएगा फिर. हमको कंक्रीट में भी करना है, स्टील में भी. To make it uniform, हमने किसी में नहीं किया. But we can do that और numbers भी चेंज हो जाएंगे. मान लीजिए सर मैंने स्टील में भी मेंटेनेंस किया, कंक्रीट में भी मेंटेनेंस किया. These numbers will change, B1 to B7. So then the whole numbers will change and it will be changed for all the three. So इसमें what we did, हमने मेंटेनेंस तीनों में से किसी का नहीं किया.
Concrete के maintenance में और उसके maintenance में there will be difference.
Difference, yes, yes, yes.
या आप जो है inducement coating की बात करेंगे या fire boards की बात करेंगे या vermiculite plaster की बात करेंगे, the same is not there for concrete.
Concrete, exactly.
To make it
difference. So I'll tell you, we are actually doing one study where
Okay.
it will be quantified. I'll show that. So final results, LGSF में we showed actually a 42% lower global warming potential, and this study is also vetted by one LC expert. So this whole thing we also got vetted by one LC expert as well. So for the whole takeaways, how many of you now know a little bit about LCA? Be very honest. Did you get the A to D, that syllabus and all those things? So I'll just quickly go through the takeaways. The takeaways was sustainability forms the foundation of modern construction. And in fact, अभी आप जब भी जाओगे sustainability की सब बात करते हैं, but most of the people don't actually know कि how to quantify it. Even we are also at the basis of it. India में भी बहुत काम नहीं हो रहा है. But when people talk about sustain, हर कोई recycling की बात करते हैं. They will have those buzzwords. But actually में क्या होता है? Many people are not aware.
After all this stratification,
Yes.
what a user is going to get?
Sir, as I said earlier, in fact, a lot of companies आज तो अब डेवलपर के नोएडा में जाओगे, गुड़गांव में अभी पहले ही बोलते हैं ये तो ग्रीन सर्टिफाइड है. दे आर चार्जिंग यू अ प्रीमियम. प्रोडक्ट्स आर आल्सो चार्जिंग यू अ प्रीमियम. आप अगर जाओगे वो बोलेंगे अच्छा मैंने तो सस्टेनेबल.
Why should I use that?
सर एज अ यूजर, द यूजर, आर यू अ डिजाइनर और आर यू, मेरे को घर बनाना है अपना.
घर बनाना.
नहीं सर, कल को जैसे आप लोन लेने जाएंगे
हाँ,
तो आपको लोन इंटरेस्ट रेट
कम मिल जाता है.
सपोज आप ऐसी बिल्डिंग यूज करें जिसमें कार्बन क्रेडिट जाता है, तो जिसमें मान लीजिए आप कंक्रीट ऑप्शन पे जाएंगे तो यू माइट बी गिवन बैंक लोन एट अ हायर इंटरेस्ट रेट क्योंकि आप कम सस्टेनेबल. आई डोंट नो दैट, बट वो जो
These are these two premium which they are charging.
सर कॉस्ट पार्ट में अभी भी द सस्टेनेबल स्टील, सस्टेनेबल प्रोडक्ट्स आर मोर प्रीमियम. अभी वो है सर, मोर प्रीमियम है. बट एज सर सेड, गोइंग फॉरवर्ड थिंग्स आर चेंजिंग.
अच्छा, कंपनीज को जो कार्बन क्रेडिट मिलता होगा
हाँ जी सर.
वो बजाय यूजर को ट्रांसफर करने के उसका उल्टा उससे प्रीमियम ले रहे. ऐसा क्यों? ऐसा क्यों? Why this?
सर यूके में तो सर थिंग्स आर डिफरेंट. अभी टाटा स्टील का तो यूके जो दे डोंट प्रोड्यूस एनी ब्लास्ट फर्नेस, दैट्स ऑल स्क्रैप स्टील.
Even more FAR is allowed for the.
Yes, yes, yes. Floor area ratio. हाँ
But
हाँ.
again, all those are to the developer.
Developer.
To the end user, there is no benefit
No.
which is passed as of now.
As of now. As of now सर हाँ. End user, मैं अगर कंज्यूमर घर बना रहा हूँ,
Be
मैं
happy that you are living in a
sustainable house. I'll just quickly, we are already out of time, so I'll just quickly, just 1 minute more. The second thing we saw, the emissions, that whatever emissions are happening, it actually needs to be quantified. And third, EPDs जो आपने देखे थे, EPDs were I guess marks. So EPDs are basically जो आपका प्रोडक्ट होता है उसके कितने कार्बन मार्क्स होते हैं. finally digital tools, जो आपके tools that we are using, they just like STRAT, just like ETABS, just like any other tool you have, they are actually facilitating the sustainability analysis. And last but not the least, आप कौन सा मटेरियल यूज कर रहे हो will have a huge effect. And also आप जब आपका लाइफ साइकिल खत्म हो गया, what you do with your product, that will also have a huge impact on your carbon. क्योंकि जब हम मटेरियल लेते हैं तो मैं बस उसका इनिशियल कॉस्ट देखता हूँ, बट जब सस्टेनेबिलिटी की बात करते हैं तो वी हैव टू लुक एट दी मैंने कौन सा मटेरियल लिया एंड व्हाट इट इज गोइंग टू डू एट द एंड ऑफ द लाइफ. And just the final slide, the same project as Abhay Gupta sir said and sir said, we are actually extended it. This is one of the first kind of studies that we'll do in India, जहाँ पे ये जो सर आपने मेंटेनेंस वाली चीज़ें और एंड ऑफ लाइफ वाली चीज़ें बोली, we are going to do one project on it. So this will be completed this year, and we want someone from IIT Indore because we are doing here, so we'll give some preference to IIT Indore. So you can apply and we'll be happy to onboard you for this.
This is going to be online.
This is work from home, and it's paid, and you will get recognized from us as well. So with this, thank you so much. You can connect with me on thank you.
Thank you, sir. Now I request Dr. Ravinder sir to present the memento to Mr. Munir.
Thank you, sir. Thank you so much. Thank you, sir.
Now we'll take a break for lunch, and lunch has been arranged in the executive dining hall at the central dining hall. Everybody is please requested to proceed. Yes, and sales session will be starting sharp at 2:30 p.m. Please be back by 2:30 p.m.
वो तो अभी निकल रहा है.
EV आ गई.
पवन सर, सेल का लंच के बाद, सेल का के बाद. अच्छा अच्छा, क्या बात हो गई. हाँ एक्चुअली क्या है कि वो इन्वेस्ट हो रहे हैं. हाँ चीफ गेस्ट भी जाना चाह रहे हैं. सर आई गेट इट सर. इसमें हमको सर ये तो होता ही है सर.
Sir, in slide number 26, you have shown carbon marks for different grade, E250, 350, 450. But the quantities are also different, right? And we can see if the quantities are less, the carbon marks are less. So if you can tell me the per ton consumption of, let's say, I use then it is not apple to apple comparison. No, let's say I have used 1 ton of E250 and somebody used 1 ton of E350. Then the quantity of carbon marks will be no, assuming same level.
उनकी भी मैं डाउनलोड कर देती हूँ मेल पे है. आप पीपीटी हाँ हो जाएगा वैसे तो, बट पीपीटी विल बी बेटर क्योंकि लाइव स्ट्रीम हो रहा है ना तो उसमें. हाँ मेल कर दीजिए सर, मैं अपना मेल करवा
Now we are going to proceed for the next session by and the presentation by SAIL. We now have a presentation by the Steel Authority of India Limited, who is also the industry partner for today's technical seminar. We have with us the team of SAIL, and it is my privilege to invite Mr. Dipinder Singh Thukral, sir, who is the general manager of SAIL, and he'll deliver the today's presentation. Welcome, sir.
गुड आफ्टरनून गुड आफ्टरनून एक छोटा सा प्रेजेंटेशन रहेगा मेरा। पहले जो प्रेजेंटेशन देखी है उसके मुकाबले में शायद ज़्यादा अच्छा ना हो। विल बी कंसंट्रेटिंग मोस्टली कि हम लोग क्या बना रहे हैं, कहाँ पे बना रहे हैं, सारा उसी पे रहेगा। मैडम जनरली हम लोग स्ट्रक्चरल्स को इन शेप्स से समझते हैं। पहले वाला हब जो है ये फ्लैंज्ड बीम्स है, सेकंड एक पैरेलल फ्लैंज बीम है, थर्ड इज चैनल, फोर्थ इज एंगल एंड फिफ्थ इज प्लेट। एक स्ट्रक्चरल फ्रेम को देखेंगे तो उसमें जो हॉरिजॉन्टल मेंबर है आपका, ये एक इसको हम कॉलम कहते हैं। जो जो वर्टिकल मेंबर है उसको कॉलम कहते हैं, हॉरिजॉन्टल वाले को हम मेन बीम कहते हैं, एंड जो छत को सपोर्ट करने के लिए रहता है दैट इज़ कॉल्ड अ जॉइस्ट। IS 808 में वैसे तो कई सारे शेप्स हैं सब इंडियंस, इसमें जूनियर बीम्स, लाइट वेट बीम्स, मीडियम वेट बीम्स, बट इसमें ज़्यादातर कोई बनाने वाला नहीं है। बीम्स, कॉलम्स, चैनल्स, एंगल्स सब IS 808 में डिफाइंड हैं। शेप इसकी जो डेफिनेशन है, डेप्थ, ब्रेड्थ, थिकनेस ऑफ वेब, थिकनेस ऑफ फ्लैंज, फ्लैंज का स्लोप, एंड जो रेडियस ऑफ रूट रेडियस, ये सारा हमारा जो है इसका IS 808 डिफाइन करता है। EN में जो EN स्पेसिफिकेशन है विच इज़ यूज्ड बाय यूरोप, इसमें भी जो सेक्शंस यूज कर इनको डिफाइन किए हुए हैं दैट इज़ पैरेलल फ्लैंज सेक्शंस, वाइड फ्लैंज सेक्शंस, एक्स्ट्रा वाइड पैरेलल फ्लैंज, वाइड फ्लैंज कॉलम्स, ये सारी लिस्ट है। इसमें से नाउ काफ़ी सारे जो हैं हमने IS 808 में भी असिमुलेट कर लिए हैं। A6 ऑल्सो अमेरिकन स्टैंडर्ड्स जो है वो भी ऐसे कई सारी ये शेप्स डिफाइन करता है, WHP, SM, C, MC, L, शीट पाइलिंग एंड बार्स। हम लोग अपना जो ब्रांड करते हैं दैट वी कॉल्ड एज नेक्स, दिस इज बेसिकली पैरेलल फ्लैंज बीम्स फ्रॉम सेल्स। इसकी डेजिग्नेशन जो है एक नॉमिनल डेप्थ्स इनटू नॉमिनल फ्लैंज एंड मास। अगर कोई कहेगा NPB 300 इंटू 150 इंटू 36.53, इसमें 300 इसकी डेप्थ होगी, 150 इसका जो फ्लैंज होगा, एंड जो मास होगा 36.53 kg पर मिलीमीटर। हम लोग हंड्रेड्स mm से लेके 750 mm तक ये बीम्स बना रहे हैं। वाइड पैरेलल फ्लैंज बीम्स आल्सो हम लोग बना रहे हैं। इसकी अगेन जो डेजिग्नेशन है नॉमिनल डेप्थ इनटू नॉमिनल फ्लैंज विड्थ एंड मास, इन तीनों से आती है। अगर 450 इंटू 300 इंटू 139.76 लेके चलते हैं तो 450 इसका डेप्थ रहेगा, 300 इसका फ्लैंज रहेगा, और बीम का मास जो रहेगा 139.76 kg पर मीटर रहेगा। 200 से 450 तक इसका हम लोग बना रहे हैं। डबली सिमेट्रिकल रहते हैं सारे, एंड इनसाइड वाले फ्लैंज वाले जो सर्फेसिस हैं दे आर क्वाइट पैरेलल। फ्लैंज की विड्थ जनरली लोअर देन डेप्थ है, एंड इसमें हम लोग जो ये ऑप्शन रहती है इसमें हम कई सारे वेट्स आपको दे देते हैं। आप हैवी, मीडियम, लाइट जो आपको रिक्वायरमेंट हो हम वो सब दे देते हैं। कैन बी यूज्ड एज बीम्स और कॉलम्स डिपेंडिंग अपॉन द लोड्स। एंड एक डिज़ाइन की कंसिडरेशन में DB रेशो जो है इट इज़ वन ऑफ दिस फैक्टर्स विच डिफाइंस द स्ट्रक्चरल यूजेबिलिटी। हाई DB रेशो जो होगा उसमें ग्रेटर बेंडिंग रेजिस्टेंस मिलता है इन द वर्टिकल डायरेक्शन, बट इसकी लेटरल स्टेबिलिटी जो है वो रिड्यूस रहेगी। लो DB रेशो जो है इसका टॉर्जनल एंड लेटरल स्टेबिलिटी इसकी बढ़ जाती है, लेकिन बेंडिंग एफिशिएंसी इसकी कम हो जाती है। आई प्रोफाइल्स जो हम जिसे NPB कहते हैं, ये हम लोग इसका जो DB रेशो है ये ज़्यादा होता है, और इसमें लॉन्ग स्पैन बीम्स अगर जो वर्टिकल लोड्स कैरी करने के लिए इसमें ज़्यादा सुटेबल है। H प्रोफाइल्स जो हैं या W जो कि WPB जिसे कहते हैं, दे हैव लोअर DB रेशो। इनका जो ये कॉलम के लिए ज़्यादा अच्छा रहेगा और इनकी ज़्यादा स्टेबिलिटी आएगी। सेम थिंग एक तो थोड़ा सा इसका टेबुलेटेड फॉर्म में। वी हैव 4 मिल्स विच आर प्रोड्यूसिंग स्ट्रक्चर्स। एक ISP हमारा बर्नपुर में है जहाँ पे हमारी एनुअल कैपेसिटी 8,50,000 टन है। दुर्गापुर स्टील प्लांट में हमारी 2 मिल्स हैं। नई वाली जो है मीडियम स्ट्रक्चरल मिल है जिसमें हमारी कैपेसिटी 1 मिलियन टन है साल का, 10 लाख टन। एंड एक सेक्शन मिल है जिसमें कि हम 2 लाख टन पर एनम के बेसिस पे करते हैं। ये हम लोग इसको प्रैक्टिकली हम शट डाउन कर चुके हैं इसको। वंस इन अ वाइल ओनली कोई ना कोई सेक्शन हम इसको रोल करते हैं। और भिलाई में हमारा जो एक मर्चेंट मिल है, इसमें हमारा 8,50,000 टन का कैपेसिटी है इसमें। बट बिसाइड्स द एंगल्स हम लोग जो बनाते हैं, इसके साथ में हम टीएमटी बास भी इसी मिल से बनाते हैं। नई वाली जो हमारी मिल्स हैं दुर्गापुर और बर्नपुर में, एक्सएच मेथड ऑफ रोलिंग हम इसमें लगाते हैं। इनपुट मटेरियल इसमें बीम ब्लैंक रहता है। इसमें टेंडम रोलिंग ऑपरेशन है इन कॉम्पैक्ट रोलिंग ग्रुप्स। इट इज़ जो इसमें जो कन्वेंशनल वाला जो है, ये पहले वाली फोटोग्राफ आपको दिखेगी, इसमें हम इस तरीके से नहीं करते हैं। 2 सेट ऑफ रोल्स हैं, एक पहले रोल करता है, एक बाद में करता है। पहले आपको एक्स फॉर्म में हमें उसका रोल होता है और देन इन एच फॉर्म। इसमें हमें वी गेट लेसर ऑफ दिस रोल का जो रिडक्शन जो वियर है डेट इट गेट्स रिड्यूस्ड। अलाइनमेंट हमारी बेटर रहती है हर डायमेंशन में। एंड साइमल्टेनियसली रिटर्निंग ऑफ रोल जो है, जो ये हमारा जो डाउन टाइम जो है ये भी रिड्यूस करती है। मटेरियल का लॉस जो है ये कम है एंड हमारी ओवरऑल कॉस्टिंग इसमें कम आ जाती है। वी हैव क्लोज डायमेंशनल कंट्रोल एंड बेटर सरफेस फिनिश। प्री सेटिंग ऑफ सिस्टम ऑफ मिल हम इसमें यूज़ करते हैं। ऑप्टिमम सेटिंग ऑफ रोल गैप अपॉन चेंजिंग रोलिंग प्रोग्राम, जिससे कि हम कई सारे सेक्शंस एक ही उसमें कैंपेन में हम निकाल सकते हैं। ability to compensate the varying lateral spread and shrinkage behavior of different grades of steel। इसमें जो different strength of steel हमें चाहिए उसको भी हम इसमें मैनेज कर लेते हैं। Beams of wider flange and thinner webs can be rolled and wide range of product mix is also possible। साइज मिक्स हमारा आप इसमें देखेंगे 100 से 750 तक है। दोनों दुर्गापुर और आईएसपी में हम लोग इसको बनाते हैं। इसमें ज़्यादातर में आप देखेंगे कि हम लोग इसमें मल्टीपल वेट्स से मल्टीपल सेक्शनल वेट्स हम आपको दे पा रहे हैं, विच विल हेल्प यू टू डिज़ाइन अ नंबर ऑफ स्ट्रक्चर्स अप टू 6 कह लीजिए कि कई सेक्शंस में ये सेक्शनल वेट अवेलेबल है। और डिपेंडिंग अपॉन द डिज़ाइन लोड्स आप इसको चूज़ कर सकते हैं। नीचे वाला जिसमें ज़्यादा लोड आएगा उसमें आप भारी लीजिए। ऊपर में जहाँ पे लोड कम आएगा आप उसको कम वेट पर वाला ले सकते हैं। सिमिलरली WPB 150 से लेके 450 तक हम लोग बना रहे हैं। अगेन हम इसमें आपको डिफरेंट सेक्शनल वेट्स की अवेलेबिलिटी इंश्योर करवाते हैं। बिसाइड्स दिस हम लोग UB एंड UC भी बनाना शुरू किए हैं अभी। ये EN में EN स्टैंडर्ड्स में आता है। वी हैव स्टार्टेड विद 203, 356 एंड 406। ये 3 सेक्शंस अभी हमने ये बनाने शुरू किए हैं। बिसाइड्स दैट नॉर्मल जो पहले कॉमनली यूज़ होते थे ISMB फ्लैंज सेक्शन जो थे, ये भी हम अभी बना रहे हैं। बट इसकी जो अवेलेबिलिटी है इट इज़ वेरी लेस। 100 mm to 300 mm तक ही अवेलेबिलिटी है। चैनल्स जैसे आपका जो रिक्वायरमेंट होगा 75 से 400 तक आपको दे रहे हैं सब। एंगल्स 50 से लेके 200 तक एज रिक्वायर्ड वी कैन प्रोवाइड। ग्रेड्स में हम आपको 250, 350 एंड 410 रेगुलर बेसिस पे है। B0 एंड C ग्रेड कैन आल्सो बी सप्लाइड। EN की जो 1025 में 275, 355 विद CE मार्किंग अगर रिक्वायर्ड होगा वो भी दे देंगे। कॉपर एडिशन जहाँ करोजन रेजिस्टेंस के लिए चाहिए वो भी हम आपको दे देंगे। वेदर रेजिस्टेंस 11587, 480 एंड 480B ये भी हम आपको प्रोवाइड कर सकते हैं। इनके जो NP जो हमारे नेक्स्ट की जो रेंज है, इनके जो कई सारे जो बेनिफिट्स हैं, steel's inherent strength and high strength to weight ratio is exploited in resource efficient structures and buildings. Long span steel solutions create open column free space that is responsive to changes in building use. Service integration with structural depth of steel frames not only reduces cladding cost but also enables additional floors to be constructed in multi-story building. Recycling का नीप जी ने कवर किया था हमारा 100% रिसाइकलेबल है. बहुत कम वेस्टेज इसमें जनरेट होती है एंड स्टील आपका जो कंस्ट्रक्शन साइट है इसके ऊपर में वेस्टेज इज़ प्रैक्टिकली ज़ीरो. Comparison of parallel flange and conventional sections. A wider choice of sections is available, sir. और ऐसे आपको दिखाया कि मल्टीपल सेक्शनल वेट्स में हम दे रहे हैं आपको, जबकि जो ट्रेडिशनल जो सेक्शंस हैं उसके ऊपर में सिंगल वेट ही अवेलेबल रहता है. लार्जर सेक्शंस इज़ अवेलेबल. ISMB वगैरह जो है से 600 तक ही आपका जो मैक्सिमम अवेलेबल है, जबकि इसमें 750 तक हम लोग आपको दे रहे हैं. They are mechanically more efficient, higher axial load carrying capacity, sectional modulus and bending strength, and reduced residual stress, and इसमें tendency for buckling is less. जो वेट रिड्यूस के चलते व्हील से के इसमें जो ट्रांसपोर्टेशन कॉस्ट वगैरह है आप वो भी ज़्यादा ले सकते हो कि उसमें जो लेंथ आपको जो एक किसी कह लीजिए कि जो ट्रांसपोर्ट करनी होगी आप एक ट्रिप में ज़्यादा लेंथ आप ले कैरी कर सकते हो. हाई स्ट्रेंथ स्टील इज़ अवेलेबल. इसमें कॉस्ट आपका ओवरऑल कम हो जाएगा. प्रोडक्टिविटी, हाई प्रोडक्ट फ्लेक्सिबिलिटी इज़ देयर. वाइड रेंज of width, flange thickness and web thickness combination for any nominal depth is there. Mechanically they are more efficient, higher bending strength for beams and higher axial load carrying capacity for column. Structurally they are more stable, greater radius of gyration, lowers slenderness ratio and allows withstanding of buckling to great extent. Overall आपको एक lighter इसमें structure मिलेगा. There's ease of fabrication. आपका जनरली जो कह लीजिए कि ट्रेडिशनल जो फ्लैंज्ड वाला सेक्शन है उसमें इट गेट्स वेरी डिफ़िकल्ट. आपका जो वेल्ड जो है कह लीजिए कि अगर कर रहे हो आप उसमें ज़्यादा आपको जगह नहीं मिलती है. यू हैव टू यूज़ टेपर्ड दिस थिंग वॉशर्स, तो वो भी है. बट का अगर दो साइड्स अगर दो आपको लेंथ्स अगर वेल्ड करनी है दैट इज़ डिफ़िकल्ट. वही अगर आप कंपेयर करेंगे इन पैरेलल फ्लैंज यू आर एबल टू डू इट विद मच मोर ईज़. कॉलम में जो कहीं पे भी आप इसमें वेब में स्टिफनर्स अगर लगाते हैं दैट आल्सो इज़ वेरी ईजियर, क्योंकि इसमें स्ट्रेट आपको पैरेलल आपको सेक्शन मिल रहा है. एक कंपैरिजन हमने अगेन एक बनाया था ट्रेडिशनल सेक्शंस और नेक्स्ट वाला जो हमारा जो पैरेलल फ्लैंक सेक्शन है उसके लेके कुछ जो लोडिंग कंडीशंस हमने उसमें ली थी. डेड लोड ऑफ 400 kg पर मीटर ऑन फ्लोर बीम्स एंड 100 kg पर मीटर ऑन रूफ बीम्स. Live load of 1000 kg per square meter on lower floor level and 600 kg per square meter on mid level floor and 200 kg on roof beam. Wind load 300 kg per meter on each column in x and z directions. इसके अगर हम कंपेयर करते हैं तो यूज़ करते हुए वेरियस सेक्शन जो ट्रेडिशनल सेक्शंस का 9.9 टन का पूरा स्ट्रक्चर बना है. वही चीज़ अगर हम इसमें बना रहे हैं अगर यूजिंग NPB एंड WPB दैट इज़ ओनली 7.6 टन्स, लगभग 23% की आपकी सेविंग हो जाती है. यूटिलाइजेशन मेन जो आपके जो स्ट्रक्चर्स हैं उसमें 0.8 से ऊपर जा रही है. वी कैन फर्दर बेनिफिट बाय यूजिंग हायर स्ट्रेंथ स्ट्रक्चर्स. उसमें लाइटर सुपर स्ट्रक्चर हो जाएगा. Upfront saving in cost due to lesser weight of steel, reduced depth of beams, greater load carrying capacity for same depth of column used in mild steel, reduced cost on account of transportation, handling and fabricating lesser quantity of steel. Bigger basket size is available, sir. आप इसमें जो हमने दिया है there are 73 sizes considering sectional weight and NPB, WPB, UB, UC पूरे लेके इसके comparison में जो beams conventionally use हैं only 8 to 10 year available. पोल के लिए एक WPB हमारा हमने इसको कहते हैं कि इसको आप यूज़ करें. कंपैरेटिवली लाइटर स्टील मेंबर विद हायर सेक्शनल मॉड्यूलस, savings in cost due to lower weight of steel member, easier connection due to parallel flange, reduced cost on account of transportation, handling and erection, superior finish, supply in specific length. इसमें स्टेट इलेक्ट्रिसिटी बोर्ड्स ऑफ ओडिशा एंड झारखंड, दे हैव ऑलरेडी अप्रूव्ड यूज ऑफ WPB 160 इन एज अ पोल. Applications: industrial buildings, utilities buildings and car parks, columns, beams, portal frames, hangars, posts, monorails, crane girders, multi-storied steel buildings, H-beams with composite construction of multi-story buildings, road bridge composite structures construction, technological structures, railways, material handling system, ports and harbors, offshore drilling reels. प्रीफेब्रिकेटेड शेड्स, ये आप जस्ट एक फोटोग्राफ दिखा रहे हैं. मल्टी स्टोरी बिल्डिंग्स कैन बी डन विद दिस. कार पार्क आपसे जो बात कर रहे थे हमारे कलीग्स. प्रीफेब्रिकेटेड वेयर हाउसेस. बिसाइड्स द स्ट्रक्चर्स, प्लेट्स आर ऑल्सो अवेलेबल सर, HSM प्लेट्स एंड PM प्लेट्स. NPM हमारा रोडकेला में जो सबसे नया मिल है, इसकी 9,20,000 टन पर एनम की कैपेसिटी है. 6 mm से 100 mm तक हम देते हैं विद विड्थ ऑफ 1500 से 4.1 मीटर वाइड एंड लेंथ ऑफ 6.3 to 15 मीटर्स. रोरकेला में एक और हमारी जो पुरानी मिल है, उसकी 3 लाख टन की कैपेसिटी है एनुअली. 12 से 63 mm थिकनेस तक रोल करते हैं. 1500 से 2500 विड्थ आपको मिल जाएगी. लेंथ फ्रॉम 4.5 to 12 मीटर्स. बिलाई की प्लेट मिल हमारी सबसे पुरानी है. 12 लाख टन पर एनम की कैपेसिटी है विद थिकनेस रेंज ऑफ 8 to 120. विड्थ रेंज 1600 से लेके 3200 mm तक एंड लेंथ फ्रॉम 4500 to 12.5 मीटर्स. TMT बाज तो ऑफकोर्स हमारा है ही है. 2 तरीके से हम बेचते हैं सर. सेल EQR हमारा रिटेल के थ्रू जाता है और सेल EQR हमारा जो है नॉर्मल जो प्रोजेक्ट्स को हम जो सेल करते हैं. Again, we have 3 mills there. Bar and rod mill at Bhilai Steel Plant, 9 लाख टन पर एनम बनाते हैं. ISP में भी सिमिलर कैपेसिटी की मिल है और दुर्गापुर में एक जो मिल है उसमें 3,60,000 टन हम लोग बना रहे हैं. This is of course augmented by number of facilities outside our plants, जहाँ पे हम अपना रॉ मटेरियल देके कन्वर्ट करते हैं. थैंक यू. सर अगर TMT की बात करेंगे तो आई थिंक वी मेन प्रोड्यूसर्स एज अ होल. आप स्ट्रक्चर्स में सर हमारा इसमें 30 to 40% हमारा है लगभग, क्योंकि इसमें अगर आप है सर RINL थोड़ा है बट ऑप्शंस बनाने के लिए यल है. वी आर सप्लाइंग.
Thank you, sir. And now I would request Sandeep.
Then she can. Is it? Is it?
Kutumbale, founder of Oxin and in structural engineering, infrastructural and firm Dar Engineering. He is also would like to invite engineering he is also profi. Would like to invite
कि जो हमारे लिए और अथॉरिटी इन विंड इंडिया जय मैं भी फादर भी पूछते हैं नहीं सर भी थे ऑडियंस में स्ट्रक्चर्स यूजिंग हॉलो सेक्शन प्रेजेंटेशन देख रहे थे उसमें हॉलो सेक्शन प्रेजेंटेशन में बताया कि लोएस्ट एज पर हिज कैलकुलेशन या कार्बन बात these hollow sections design when we hollow important and hollow section design at this topic not so much so this topic not so much so I will take you through as we I will take you through as we next time let's say you are doing some steel इसमें I section next time let's say you are doing some steel इसमें I section की जगह if intention with this session today की जगह if intention with this session today manufacturing hollow sections and Apollo sort of goal today that sir as builders and very sir for of illustrious speaker तो मेरी wife taking care illustrious speaker तो मेरी wife taking care of for which we were discussing IS 800 2000 from of for which we were discussing IS 800 2000 from design detailing code so referring to so we have 50 instructions so we in hollow section so when I say if you biomimic bit ratio is hollow section अंदर sections are strength and issues आते हैं और this is called as upside and now each of them goes away when that problem sections no torsional and lateral torsional buckling अगर आपने IS hollow sections it says that you do not laterally restrained beam वो IS 800 में आप get a very good practical idea just for understanding per will be 200 400 don't go into the press 300 flange both these sections have same cross section for area this will come out to be a software you can do it in any so I have applied axial load लगाने के बाद factor is 18 right now okay मतलब मेरे buckle होगा lower is the buckling factor and this is an I shape that I have this is prone this I section will be prone hollow assumption of steel is happening I section would hollow assumption of steel is happening I section would do cross section area if it is having significantly high compression capacity that is offered by the section area if it is having significantly high compression capacity that is offered by the both are the same this is the lateral goes out of plane these are the same this is the lateral goes out of plane is so prone to most insignificant price की as a beam आप कोई section economy dan so this is the structural reason now economy dan so this is the structural reason now secondary मिल जाता है because so that there is one aspect of using tubes also so reasons between so if you look at in case of compression but still reasons between so if you look at in case of compression but still in the entire for steel design in calculation the web buckling properly explained these so their calculations we explained these so their calculations this gives options so if you want to this gives options so if you want to 9 for it मैंने आपको दिखाया 9 for it मैंने आपको दिखाया कि कैसे ली 5 है कि कैसे ली 500 okay grade wing 200 okay grade wing 202 y202 y200 web depth is cross section of both of them is web depth is cross section of both of them is area पे या weight terms में करते हैं तो दोनों का area पे या weight terms में करते हैं तो दोनों का so therefore I have kept this show you calculations so therefore I have kept this show you calculations because tension capacity both will because tension capacity both will give now the HSS column this would be now the HSS column this would be the compression तो अगर आप strength would be the compression तो अगर आप strength और hollow section में defining criteria so और hollow section में defining criteria so but I am getting 3 type capacity but I am getting 3 type capacity that also is significant so okay that also is significant so okay there because there are no low there because there are no low and then this is the shear capacity along width it is much then this is the shear capacity along width it is much more economic hollow sections instead of much more economic hollow sections instead of tricky part is connections there are problem tricky part is connections there are problem here suppose here suppose on your shape will have a tendency of problem of on your shape will have a tendency of a problem of resisting so ये local wall plus connection strength, so the member is good, so ये local wall plus connection strength, so the member is good. Ask you according to you which of the connection दिखाए हैं, अगर मैं same full offer which of the connection दिखाए हैं, अगर मैं same full offer me more connect, this force is me more connect, this force is lightning in between connections which will offer me lightning in between connections which will offer me choose ना कर पाए, and this is choose ना कर पाए, and this is well covered in a separate, and if you want is well covered in a separate, and if you want to detailed, but what I will show I have taken from idea static detailed, but what I will show I have taken from idea static this type of a connection, ये हमारा वो type 1 this type of a connection, ये हमारा वो type 1 type of, if I have a local failure of this type of, if I have a local failure of this orientation, and let us compare orientation, and let us compare their newtons of, and it आ गई हमारी their newtons of, and it आ गई हमारी, अब ये इफेक्ट को रोकती बट ही आ गई हमारी, अब ये इफेक्ट को रोकती बट ही, अब ये इफेक्ट को रोकती बट ही एक्शियल change the orientation side wall change axial change the orientation side walls instead of a good orientation axial change the orientation side walls instead of a good orientation point needs to be highlighted walls might be increase the overall moments in stiffener plate over here, overall moments in stiffener plate over here, anything more than that it will be moments in stiffener plate over here, anything more than that it will be, I added anything more than that it will be, I added a 6 mm stiffener connections in hollow sections, so 6 mm stiffener connections in hollow sections, so stiff sections बनाना easy और extended, थोड़े से problems बता रहा connections, yes he said go for bolting in shapes, so this and then you are bolting this is side plate pre-qualified connection, also this face connection assembly रहेगी. Another problem with this, in seismic provisions we require the beam and column पड़ेगा, but then this is all welded. In addition, when it comes to the usage of to properly design, जैसा मैंने दिखाया कि सिर्फ configured with hollow section, we are so used to use, but in hollow sections we have to, is specially challenging कि designed for, as you know, जिस तरह, so similarly we does not allow us the unisymmetric I section shapes के your seismic frames, braced frame system use कर रहे हैं, तो उस, this is as per our Indian code right now, allows us to use the, so maybe in future hollow sections for beams and not allow us, so agar code right now to go for from the 18168 use of American code over here, and in, as I told you, require lot of and go on increasing, case.
You are headed this way. I can tell you are headed this way. I can definitely tell you
Calculations to
in that case because it's more concentrated in that case because it's more concentrated top and bottom
for beams, but
they are even in the columns,
but this is for ties
so it cannot be general
specific applications.
most in the conditions
Yes sir.
so it cannot be general
Specific applications.
most in the conditions
Yes sir. Restricted by not use, maybe we can achieve more economy in standards. So restricted by not use, maybe we can achieve more economy in standards. So sections as a moment connection out of a moment connection, the required hollow section out of a moment connection, the required hollow section to hollow section connection system, connection system you may through this, तो only I section में through this, तो only I section should करने का try कर सकते through this presentation, करने का try कर सकते through this presentation them during the तो आज सर से I have
sharing your valuable Mr. Ashu. Proceed currently working as one holds up petic behavior. Currently working as one holds up petic behavior. In consultical content to kindly begin the content to kindly begin the
Good afternoon. Good afternoon, everyone. Professor Pavan sir. I'm Dr. Siddharth. Good afternoon, everyone. Professor Pavan sir. I'm Dr. Siddharth Chauhan. Today, so it is an overview. As this is expect, what are the let us see. So this is my bio. I did my PhD in elevated temperature, 6 months only. Then we'll do of the cases that has the advantage forwards and for the second large Gati Shakti overs and men be taken care highway bridge while the of the so I BS the data so it may fail. So these are the option. Vivek construction phase. Failure where 1% was steel concrete containment timber bridge suspension.
Dr. Vivek,
please. No, it's okay. Currently in near future. Yes.
It's more for manufacturing. Usually is pilot trust to
are from civil in case of
law or
related told that I will again add